Hi, it's me, Tim Dodd, the Everyday Astronaut. Today is a pretty exciting day. It's a first launch of a really exciting rocket. I mean, this is the world's first 3D printed, mostly 3D printed. When I say 3D printed, not like just the engines, we're talking pretty much the entire rocket, like 85% of this rocket, 3D printed. It's just so cool. And this could also be the first Methalox rocket ever make it to orbit. So as we ramp up and try to, figure out what's going on, let's, of course, go on over to a little thing called our pre-launch previews. And you can go to those by going to everydayastronaut.com. Anytime you want to know even the T0 time of a rocket launch, obviously we've got it here on our screen over on the top left hand of your screen. But even on our website, everydayastronaut.com, you can see a little thing that does a countdown for how long until this launch. Today's launch is called Good Luck, Have Fun, the first launch of Relativity's Terran 1. So let's go through this here real quick. As you can tell, like I said, we're well, maybe you can't really see that too well right now because of the opacity. It's like really hard to read. But yeah, we are T-minus 25 minutes away from this first launch. Really exciting. So this is subject to change as it already has. I think it's already, it's already into 1820 UTC time. So that's going to be 1:20 Eastern PM. The mission name, Good Luck, Have Fun. Launch provider for this is Relativity Space. The customer is Relativity Space. The rocket is Terran 1. The launch location. Now this is interesting. I was trying to get to the bottom of this yesterday and I didn't end up quite getting to the bottom of it. It's Launch Complex 16, but it's at Cape Canaveral Space Force Station. And normally launch pads at Cape Canaveral Space Force Station say SLC, Space Launch Complex. And I think the reason is, I think it's because previously this was a sounding rocket or something. It wasn't an orbital launch complex, maybe. So therefore, it wasn't Space Launch Complex, it's just Launch Complex. Does that make sense? I still don't actually quite know why. I had a couple different people explaining it. Maybe, yeah, I don't know. For whatever reason, it is a launch complex, not a space launch complex. Normally, when you see LC, like 39A, those are the ones at Kennedy Space Center. So this is the first time I've seen just LC-16. So, all right, let's keep going here. The payload mass. There's no real payload on this. There's a 3D printed metal ring weighing about 1.5 kilograms. So this is purely just a, let's test this thing out, make sure everything works out before we fly anything on it. I believe the metal ring, though, was the first thing that they ever actually 3D printed with their massive 3D printer. The satellite is attempting to go to a 200 by 210 kilometer low Earth orbit at 28.5 degree inclination. So 28.5 degrees means they're flying straight east out of Kennedy Space Center, or Cape Canaveral technically, straight east, and that puts it on that 28.5 degree inclination. This is, will they be attempting to recover the first stage? Nope, not a capability of Terran 1. It will be a capability of Terran R, their next rocket that they're already working on like crazy. Where will the first stage land? It will crash into the Atlantic Ocean. Will they be attempting to recover the fairings? Nope. Are these fairings new? Yes. Weather is currently 90%. Actually, I think I saw a thing saying 100% already. So that's fantastic. This will be the first mission for Relativity. The first launch from LC-16 in 35 years. First launch of Terran 1. First launch of a 3D printed rocket. 32nd orbital launch attempt of 2023. And like I said, this could be, technically this kind of could be two other firsts. It could also be the first Methalox rocket, first orbital Methalox rocket. And it could also be sort of the first, if this succeeds on its first launch attempt, or its first time leaving the ground. Because, it might get scrubbed today for weather or other technical reasons. But assuming it doesn't do that, and say it makes it into orbit, it could be the first fully privately funded rocket to orbit. Kind of. Pegasus actually would have had that in 1990. It was technically private funded, but most of it was kind of, it wasn't necessarily a clean sheet design. It was pretty well derived from defense hardware. So I would kind of give them the cake. I don't know. Each of them deserve the first in different ways. But yeah, this. If you want to learn more about this incredible rocket, here's the payload that they're going to see on it that hopefully will make it into orbit. We've got here what we're looking into. We're already well within the terminal count. So we hopefully will see engine ignition at T-minus 6 seconds. And here's your launch timeline, all of this other stuff. We've got a nice write-up here of all of the things that we would expect to see in this launch and why 3D printing is exciting. This was written by Flo, so everyone say thank you to Flo for writing this article. I'm gonna actually shut up and listen in to the launch because I want to see how things are going. Because we actually already have. All right, it is up. There's just music playing right now. I will turn up. Ooh.
From Mission Control, we did just get an updated tee time from the range of 1400 Eastern. Again, that's 1400 Eastern. That'll be reflected shortly on the T clock. There you go. We are now 1 hour away from our launch.
All right. Well, we just got an updated T0 right as I start of 1 hour. So it looks like we're not going to be short. Oh, unfortunately, I got to move our clock because that's going to be really annoying on top of their clock. But yeah, we are definitely. Just to make sure we're not going over any on top of any of their stuff.
Our hold and extension of our T clock is due to us wanting to get more time for propellant conditioning. We're going to stand by to hear more from Mission Control, but as of now, we are launching at 1400 Eastern.
Okay. So there we go. Our T clock is correct as far as 1400 Eastern. So that would be, what is that, 1900 UTC? Yep, 1900 UTC. Yeah, sorry, I accidentally had the music still up, which is bad because I guarantee we're gonna get a copyright strike now just for that little 12 seconds of music. Oh, sometimes I hate YouTube. You know what I don't understand is if someone has music playing in the background of their thing accidentally, or say you have a 1 hour video and there's 1 minute that has, let's just say you play a full blown just normal radio hit song, you play a Bon Jovi song for 1 full minute. Why would they get all of the, like, every bit of money from that entire stream? Why wouldn't it be like 1/60th, the 1 minute that you had their copywritten material? Like, why do they get the entire right to everything? It's just like, oh, nope, copyright strike. All this money now goes to Bon Jovi or whatever. It's like, I don't get it. All right, so let's keep going here. I guess now we have plenty of time to answer questions. So let's get to that. I am working on getting everything pulled up here. Play some Kerbal from Mr. Benedict. Well, I actually do have a awesome new gaming PC. I was literally planning to fire. I've got it all pretty much fired up, ready to go, but I don't quite have OBS and everything all installed. I've been working way too hard on getting how to start a rocket engine finished, and it's there. Oh. Okay, so our clock's going to be slightly off. That's actually the delay time between YouTube and real time. So, Mary Liz, if you wouldn't mind trying to line that up. I know it's going to be a little bit of a pain, but yeah, we've got to put in about a 7-second delay. So we have to make our launch time end up being like 14 and 7 seconds. 14 o'clock and 7 seconds. Yeah, sorry. All they said about the clock was just that the clock's still going. So, yep, don't worry. I will try to turn it up whenever I can. So, yeah, anyway, we are working really, really, really hard on finishing how to start a rocket engine. It is over an hour long. It has an insane amount of animations, and we've been working really, really, really hard to get this all done. I'm trying to launch it tomorrow. That's still on track. I just published the final for review for patrons, and in Discord I posted it. So if you are a supporter and you want to get a final run through on that video, how to start a rocket engine, consider becoming a YouTube member here or becoming a Patreon supporter, and you'll see that link. We use those review times to be able to, go through and look for all the errors, all the things that would normally be a YouTube comment. We're trying to get out of the way before it's public knowledge, and that way also it helps make sure that we're factually accurate, that we're not spreading any misinformation. Kind of that's our level of academic review, is making sure that we have eyeballs on it to check for spelling and all those kinds of things. So there has been a lot. Yeah, the video comes out tomorrow. I stayed up till 1:30 last night making changes on it, only to wake up this morning and make even more changes. So that's how much like of a fine-tooth comb we're still doing in these long videos. When it's an hour long, like anytime you review it, there goes an hour. Like even if you're just like, I better make sure there's no errors, right there, 1 hour is gone. And I've already reviewed it 7 times. Like there's 7 hours of just watching over and over and over. So yeah, let's answer some questions. And don't forget, guys, you don't have to do any kind of, we don't answer just super chats or anything. We answer anything that we see good questions. So just ask a question. Hopefully one of our mods can pull it up here. This is a good question, or a more of a something that Steve. Oh no, that changes where our. Okay, I gotta move this a little bit again so it doesn't crop out there. That clock being on the top isn't great. Hang on. Okay, that'll work for now. I could actually be smart about this and do this. I think in the overlay I can actually. Hang on. Give me 1 second. I'm going to try sliding this baby down. I don't know. About like that. And update. I don't know if that updates. Ooh, cool. We have an amazing new overlay system, actually, that Colton developed. And Mary Liz and Allie. There we go. That's pretty good. That's awesome. Okay, sorry. I'm getting distracted. Back to your question. Okay, so Steve, let's put that back up here. Steve asked, so I guess this Terran 1 is roughly between the Falcon 1 and 9, and the Terran R will be like a Falcon 9. Terran 1 is actually pretty close. It's not really between Falcon 1. It's pretty darn close to the Falcon 1's capabilities. Falcon 1 was actually a pretty beefy, small lift launcher, and so is this. This is in the upper, we're over a metric ton. That is definitely big for a small lift launcher. So yeah, it's right around Falcon 1 class, and I believe Terran R is going to be around Falcon 9, but they are aiming to try to make Terran R fully reusable. And one of the first Terran R missions is planning to go to Mars. So that's obviously extremely, extremely exciting. Let's see here, from Kuro99, if they succeed, they instantly put themselves on the top companies. If they aren't, they can still try again. If all else fails, they are already the top 3D printing aerospace company. See, that's actually how I see Relativity, and why I think Relativity. So I'm a little bit critical, actually, of the fact that there's 100+ small launch companies like kind of popping out of the woodwork. To me, it takes something. You have to be doing something very novel and looking very long term. You can't be just looking to fulfill, what Rocket Lab is doing, what Firefly is going to be doing here soon, what ABL, what all of Virgin Orbit, what all these companies are, Astra. They're all trying to do kind of the same thing. And I think if you aren't already flying, like Rocket Lab, Firefly has now proven it. If you aren't already flying by now, you're really you're behind. And so Relativity, yes, I think they're kind of on the later end of this, but they're looking already way far into the future. And because they're 3D printed, I believe that. Like, I actually believe that they can easily iterate and scale up and get to that next launch vehicle without it being with a lot less work and a lot less back to the drawing board situation. So I think they have themselves set up to be able to iterate and accelerate really quickly, and I think that's extremely important. So yeah, I think and yeah, like you said, worst case scenario, they are probably the number one 3D printing company now, with just the incredible knowledge they've gained on how on Earth can even do this. And again, even more importantly, off of Earth, because they are planning to use this technology on Mars, and potentially even the Moon, to be able to make structures, vehicles, repairs, all of these things. Land one of their printers on Mars and start printing a habitat. It's that easy. I think it's very cool. Thank you so much to Maureen Gray for becoming a member. Much appreciated. Oopsies, I still accidentally. There we go. I think that's pretty good. All right, so this is, good question from Trevor in our Discord channel, and also a writer on our website. Trevor asking, I don't understand the advantage of 3D printing a tank. A tank is easy to make, and I am 100% with you. I don't entirely understand why you'd entirely 3D print, the structure. Yes, a tank is pretty darn easy. You take a flat sheet of metal, you roll it, you do a single weld, and it's done. I mean, obviously, there's more to it. There's baffles, there's a handful of other things, and that's actually probably what they figured out was, when you have race, but although it looks simple, it looks like a very round thing, a cylindrical tank. There, like I said, there are baffles on the inside. There are raceways. There's electronic runs. There's all of these other little things that, if you're iterating it quickly and don't want to have to change and do all of these big massive changes anytime you change any of your dimensions, 3D printing is definitely a way to iterate quickly. Now, I wouldn't be surprised if someday they get away from 3D printing the actual walls and the main portions of the tanks. But even when you think about like their bulkheads, they have the ability to make unique shapes that would be really hard to manufacture, and they can do that using 3D printing. So I think at this point it's almost just a flex to see like how viable is this metal? Is this metal truly going to hold up to the rigors of a orbital launch? Can we really do this at this scale? And then I think from there they'll probably, eventually as they ramp up production, ramp up and get more serious into actual regular flights, I think at that point in time, it'll be time for them to start, well, how can we actually make this a cheaper rocket? And they'll be looking at all sorts of ideas there. So for now, though, I think, it's kind of a cool idea. Let's just see how much we can 3D print, see how it does, and go from there. Kind of to that same from twin turbo Stang. Hopefully it's a V8 Mustang. Twin turbo, that would be good. Isn't that less efficient in terms of total mass? Although they do make that turbo V6. Anyway, isn't that less efficient in terms of total mass? Yeah, it is. It's like 5% less efficient. Oh, hold on.
Just joining us, we are at T minus 49 minutes. As a reminder, we set back the T clock to allow us more time for propellant conditioning. In the meantime, why don't we talk about stage 2 MDC?
Great idea. One of the approaches we take here at Relativity is to be focused on having a lot of hardware that we can test in order to reduce our risk getting into flight. One attempt that we tried to do that was paved out through successful testing was stage 2 hot fire testing. This is where we took stage 2 to NASA Stennis and we integrated the Aeon vacuum engine with a stub nozzle. For this test, we filled the tanks with our cryogenic propellant, and this is also where we were able to fire the engine and see interactions between the engine as well as the stage. What's really important about this type of testing is that it allows us to reduce risk. It allows us to test our propellant estimation algorithms. It also allows us to test how we pressurize our tanks. We got so much learnings from these tests, and why don't we take a look at that journey to stage 2 hot fire testing.
Okay, I think they've shared all of this stuff. We'll let the obviously keep the pretty footage up, but let's keep answering your guys' questions here. This is again 3D printing is obviously going to be the big topic today. 3D printing everything may not be the most efficient, but it is a huge achievement for the future of humanity. We could build the printer on another planet or the moon and just input raw materials, and that's really the long-term goal. That's how far forward this company is thinking. They really are thinking about, I think they're really trying to kind of be, assuming that SpaceX and people will be pushing towards Mars, and they want to make sure that they're aligned with that and not just competing with that. So by aligning with that, I mean, they could potentially fly one of their huge Stargate manufacturing 3D printers inside Starship and have it land on Starship and then use a Relativity 3D printer to do work from there. I'm just making up an example, of course, but by having these aligning technologies, it's really cool to think what they could be doing, what they could be offering other companies as well. So I think that's really cool. Mark, what parts are 3D printed? Did my master thesis on 3D metal printing, and gotta say that this stuff is crazy. Yeah, when I say 3D printed, literally 85% by mass of this rocket is 3D printed. That is absolutely wild. I just can't even imagine telling someone that 20 years ago. So it's really cool. I mean, even the cool thing with like rocket engines too, in particular, a lot of rocket engines are using more and more 3D printed parts. Raptor and Merlin and Super. I don't know about how many parts on Merlin. I assume a few, but Super Draco. We're seeing a lot of companies using 3D printed. The Rutherford engine on Rocket Lab's Electron is 3D printed. It makes a lot of sense because you can really make intricate channels and do all these things that would be harder to do in a traditional manufacturing sense, especially if you don't have to worry about things like bimetallics. You can do all of your cooling channels and things like that in a really unique way that would be a lot harder to maybe mill or manufacture in other ways. So 3D printing definitely can offer a lot of advantages. Like I said, it's unusual that they're doing it here on the entire rocket. Like, it is weird. I still don't necessarily understand why 3D print tanks, but again, it's almost like at this point, why not? Why not prove out this technology? Why not see how far they can take it? And then once they get into, you know, more operational and more production rates, higher production rates, see where those advantages lie, and, you know, what things just don't really end up making sense to 3D print, because, you know, it might be a ongoing trade study. This is a good question here from just a period on the screen. Isn't SpaceX's Falcon 9 also Methalox? No, it is not. Here. Speaking of Falcon 9, I'm so glad I finally have one of my own rockets in my own hands. Yeah, this has been a long time coming for me. This is the Falcon 9 booster, Falcon 9 upper stage. By the way, these are finally back in stock in our store at everydayastronaut.com/shop. And yeah, the Falcon 9 is entirely Kerolox, so it's kerosene and liquid oxygen. So this is Methalox, liquid methane, and liquid oxygen. Like that's how Starship is going to be too. Starship is also Methalox, but this is currently slated to be the first Methalox rocket to orbit. Of course, Vulcan is coming online soon, and will be flying very soon as well. We also have Blue Origin's New Glenn, which is probably a couple years away still, also flying Methalox. All right, what do they have to say?
As we continue to wait, can we get a brief update on the mission going on today?
Yes, so we are a little bit less than about 50 minutes until launch. We are still we took it back to be able to condition our propellant, so we're still doing that at the moment. But the range is green and the weather is looking great.
We are still moving forward, team. As we continue to wait, we just saw a video about Stage 2 mission duty cycle testing. We reached that full mission duty cycle duration for Stage 2. Similar to Stage 2, for Stage 1, we also completed stage hot fire testing. However, that was here at Launch Complex 16 instead of at NASA Stennis. We actually utilized our launch pad and adapted it to also have the capability to do Stage 1 hot fire testing. Let's take a look at this video.
Again, all of these videos they've posted on social media. So if you haven't seen these, I'll let them run in the background. Yeah, people were asking. Yes, that is correct. By the way, these, as you might have heard as I'm assembling it and disassembling it, it is metal. This entire rocket, except for the Dragon capsule, we kept plastic. But the whole thing is metal. It's nice and, I mean, you could whack someone across the head with this thing. It is beefy. Very, very detailed too. So we're so excited to finally have those back in stock. If you guys do want to check those out, everydayastronaut.com/shop. Yeah, get them while you can. We're running out. We do have another shipment on the way, but we're almost out of this one as well. So pop in there if you want the highest quality, most detailed Falcon 9 model rocket available. So, all right, let's keep answering questions here. Is their plan, this is from B3 Fuddled. Is it in their plan to find a way to recover the first stage? Will they use the same approach as SpaceX or just use parachutes? They won't be doing first stage recovery on Terran 1. This is really a Pathfinder vehicle. This is really a smaller scale demonstration for this company. This company is looking at this as, you know, does 3D printing work to scale? Does, you know, what issues are going to crop up? The unknowns almost. And hopefully everything works out great and they feel comfortable moving forward. I believe I don't remember how many Terran 1 launches are planned, but I think it's only a small handful. Like, I think they are planning to fly them side by side at least for a bit, but Terran R is really where things are going to get crazy because that's when they start to look into it. So look into landing and reusing the booster and the upper stage potentially. Let's see. Isn't a 3D printed rocket composed entirely of weld seams at every point? If seams are weak spots, how do they expect this thing to hold together? Seams aren't weak spots. Oh, no. A good weld is actually extremely strong. A good weld can actually be a strong point. Now, what you might be confusing is geometry. Lots of times where there is a weld, like a corner, can be a poor choice for a pressure vessel. You know, you have a point where you have two forces really trying to split something apart. A weld in general, though, like a seam weld on a friction stir seam weld, I believe is actually stronger but heavier. So, like I said, I think they said it adds maybe 5 to 10% more mass in the tanks, which that is a lot. Like I'm actually surprised that that it's just like, oh, 5 to 10%. When engineers do pretty crazy things for 5 or 10%. But again, so much of this rocket is about the tech demonstration of the viability of 3D printing a structure, the rapid, iteration of that potential, and then of course, the actual 3D printer itself. So, yeah, let's keep going here. Thank you so much to Daniel's Weather Space Station for becoming a member. I appreciate that. Again, stay tuned. If you are a member, you have the ability to check out and watch how to start a rocket engine, our newest video, which is coming out tomorrow, though, by the way. So get ready. I think I'll probably have it out by like 10 a.m.-ish Central Time, which would be 16 UTC tomorrow. So set your calendars. Click on it right away. Help that YouTube algorithm realize that this video is hopefully as great as I think it is. We put a lot of work, like way more. This is the most besides the Soviet rocket engine video, this is the most like animations and highest quality production I think we've ever made. So I hope you guys are ready for it. And again, it hits that bar. Like I love if I learned something and I feel like I walked away being like, I did not know that, and that, then I feel like it's a good video. And this video, I think there's like probably 30 or 40% of this video I had no idea the specifics of before I made this video. So I'm really, really, really happy with it, and I think you guys will learn a ton. Alexander Ash, we need more companies to create rockets. However, I struggle to understand why a client wouldn't go for Falcon 9 when it comes to cost. Yeah, good question, Alex. That is, at this point, Falcon 9 is pretty dominant. It's proven. It's flying often. There's the transporter missions. But at this point, too, though, there is a wait. Like even the transporter missions, you kind of have to wait a handful of, every, 3 or 6 months or whatever. And then you're going to get in an orbit with everybody else. You're going to get in a sun-synchronous orbit. And there's a decent chance that a small launch company doesn't want that. So let's say the Tropics missions. Those need to be on a low inclination orbit in order to work out. There's a handful of other orbits and dedicated rides. You'll hear that a lot, dedicated rides or dedicated ride share even potentially for small sat launchers. And that's the thing is like there's a lot of companies that are out there with very specific orbital needs that ride sharing on a large scale doesn't necessarily work out. So if this rocket is cheaper altogether than say a Falcon 9, like say you have two 500 kilogram payloads, right? And you need to get them to 28 degrees or something, or geostationary or something crazy. Maybe not geostationary with this rocket, but 500 kilograms to low Earth orbit, right? And you have a kind of a weird, unique orbital, requirements, let's say. And you could either buy an entire Falcon 9 to fulfill that need, or you could buy something that costs a fifth the price and can still do that mission. And hopefully, the idea of these companies, they want to be ramping up production, ramping up their flight rates to the point where they are ready to go for their customers at a drop of a hat. I know that Rocket Lab is getting to the point where their payload or their manifest is backed up just because they're waiting on customers. They're ahead of their customers, is my understanding. I think I recall hearing that correctly. And that's the way it should be. It should be like as soon as the customer is ready to fly, they should just be able to book something and fly. And the industry is getting to that point or getting close to that point. So, end the stream, then restart it, then the strike is gone. Well, I don't think we're going to restart. There's no point. I don't think we'll really have much of a strike here. Thank you to Armand for becoming a member. I really appreciate that, as well as Andy Builds. I really appreciate the support. Again, I can't wait for you guys to see this video. I think this how to start a rocket engine video is top notch. And again, I know I feel like a broken record for saying this, but it is the support of Patreon and YouTube members and even the shop and all that stuff that allows me to be able to make videos of this high quality. If I know people, it's so funny because people do get used to high production rate videos. Scott Manley, incredibly prolific video maker, and full time, like he still works full time and is a family guy. So people are like, why can't you make videos as often as Scott Manley? Well, yeah, we still are working beyond full-time hours and a team of about 3 of us nowadays on these videos. And it's just how long these videos take, that we're making what I think are TV production quality videos. These are the kind of videos that I wish, Discovery Channel or Nat Geo or History or something were making. That's what I want to be making, what I wanted to watch as a teenager and young adult on those channels. And of course, those channels, unfortunately, just totally became, Swamp Blogger 2024, The Alien Returns, Mystery Goo 3000. Every one of those channels, I feel like, just really lost touch with their core audience. And for me, I love diving deep into a topic. I just absolutely love visual representation of things as you're talking about them, and showing you, walking you through every step of processes. I find a lot of, it's hard. It's really hard, but that's the way I learn. That's the way I think a lot of my audience resonates, and a lot of you guys learn too, is by being walked through something and having the visual representations of the things that are being talked about. And so it's just become my mission that we're gonna break this down and make it as easy to follow, as fun as we can, and as visually pleasing, so you stay following along. Excuse me. So you stay following along with us. So yeah, of course, huge thank you to all of you. Yeah, thank you so much to Seisho Vibes. I did see this, but thank you for your interest in space. That really, really makes me happy. Discord are already getting cutouts of my face. Thank you guys. I love. Why? All right. Okay, this is the question. Austin Lake, can we get your opinion on when Starship may launch? I would love to plan going, but I really wish we could get a date already. I mean, right now it's looking like it still might be by the end of the month. Like, I'm hearing, anywhere from March 20th until the end of the month. I think the big unknown right now is the launch license. So we still have to wait to see that be published. And that'll be very telling when we see the launch license published. That'll be like it's go time, baby. So I don't know. I'm planning to head down there. I'll be down there in Texas for South by Southwest. I'm on a panel that I'm really looking forward to with Jack Beyer and Jenny and Ryan Shalinsky. It's going to be really fun. We're talking about new space media, basically. I can't wait for that. But yeah, and then I have to make a quick little run to California for American Ninja Warrior for my brother-in-law and my nephew, which is going to be really fun. But then from then on, I'm basically planning to anchor down and get ready for Orbital. And we've already been doing, like, I've gone down there multiple times in the last couple months just to do prep work, and some of our team members have as well, just to prepare for that launch. That launch is going to be massive. Ryan and Mary Liz with Cosmic Perspective have been working like crazy just to prepare for Starship Orbital. So that is the ultimate question: is when is Starship Orbital? I mean, signs are pointing to this month, but again, a lot of it does rely on that launch license. So, what's the update? Actually, on that note, I think it really still depends on the success of the orbital launches. We got to see some flight cadences out of Starship. We got to see that thing maturing and getting beyond just these developmental launches before any humans get near. And of course, I'll be flying to the moon after Jared Isaacman flies on Polaris 3, on the 3rd mission for the Polaris missions. Oh.
Just under T-minus 33 minutes. We are progressing well towards our launch time of 1400 Eastern. If you missed the delay, the hour push was due to propellant conditioning. We wanted to get more time to continue that operation, and we're currently doing a great job. Everything is still green and a go for that launch time.
That is great to hear. I am so stoked to keep moving forward. As we continue to wait, maybe let's take a moment to recognize the technicians that helped us build the rocket that you see on the pad today. We wouldn't be where we are today without all of their hard work and effort to build this rocket. Let's take a look at this video.
I'm seeing some really good questions come around here, guys. Keep them up. Oh wait, where did that one go? No, I think I tagged the wrong one. Here, this one. That's what I meant to do. Give me a second. I got a really good question here that I just wanted to throw in there. I caught this from Leg End. Can you make a video talking about why SpaceX is so much faster on development than NASA? Falcon 9, Starship versus SLS. already done that. Yep, I did that about 3 years ago now. Oh, coming up on 4 years. I think that was 2019 when I made a video basically titled Starship versus SLS. And the idea is really to look at the design and iteration and production and ramp up processes between NASA and SpaceX and private companies versus NASA, what that structure looks like and how NASA's really not set up to iterate. And they're very risk averse. They're really meant to do big risky things that, you can't, but like SLS is that's a big risky endeavor, building a super heavy lift launch vehicle that costs billions of dollars. They couldn't risk having it blow up on the pad. So they take just a different approach than, say, SpaceX. And we go really deep into those philosophies and even how I don't think NASA needs to be building rockets anymore. I think that obviously the commercial industry has fully proven to be competent enough to build whatever we need. We don't need NASA to be developing and engineering and operating rockets anymore. That's just a very old school, just like the FAA doesn't build airplanes, the DOT doesn't manufacture cars. Those things seem pretty absurd, but that's kind of what's happening when NASA builds a rocket. Now, there's still things that, NASA needs to be, but like who's going to be like no one just for fun is, well, except for maybe Rocket Lab, is going to be building, a Hubble Space Telescope or a James Webb Space Telescope or a Cassini or, all of these other, OSIRIS-REx, all of these missions that are really just for scientific research. There's not really a profit motive behind it. So that's what I think NASA needs to be doing, and all the Mars rovers, Curiosity and Ingenuity, helicopter, all of these different things. That to me is what NASA needs to be, is best at. That's where they're at their best. I don't think they're bad at designing rockets. It's just they're institutionally not designed to make iterations, and they have the problems of having Congress and just all sorts of politics behind everything that they do. So it's just not as easy for them to make any changes. There's a lot of momentum in certain directions, and that momentum can be good because it can prevent the rug being pulled out from underneath them. It can prevent cancellations of programs if there is a lot of momentum. But that same momentum is also what makes it really hard to change, and that can be very, very bad. Let's see if they're about to say anything. I don't think they are. This is a great question here with the perfect shot for this. This is from Arvid. Thank you, Arvid. Good to hear from you. This is a new rocket. How confident are you on the pointy end up and flaming end down? Well, this is a fantastic view to do our look here. From here, I can very clearly actually see the pointy end is up, flamey end is down, and you will notice to the right there, you see a little flare stack right there. Do you guys see that? You'll notice that the rocket is venting, and what is being vented at the rocket, that is liquid oxygen. It's okay to vent, well, it's not actually liquid oxygen. At that point, it's gaseous oxygen. So that's boiled off oxygen. So this is something we talk a decent amount about this upcoming video about how you start a rocket engine. As you're filling these tanks, as you're filling up a rocket, and even as it's sitting there on the pad fully fueled, anything that is cryogenic is going to just boil off. It's sitting inside of a thinly insulated, or in some cases not really insulated at all, tank, and that tank is more or less sitting there at ambient temperature. Obviously, it'll cool down from the cold liquid propellant inside of it. But as it warms up, that will boil it off. Obviously, that's kind of the whole point of like a boiling point. Water boils at 100 degrees Celsius, freezes at 0. Cryogenic propellants like liquid oxygen boils at minus 183 degrees Celsius. So unbelievably cold. So obviously, it doesn't take much for liquid oxygen, at least in our human welcoming environment here on Earth. It doesn't take much energy to boil off liquid oxygen. And so that's what you're seeing actually on the rocket right now is as they're loading it, and even once it's sitting there, you will see that liquid oxygen has boiled off into a gas, and that expands almost 1,000 times when it does that. So it needs to be vented out in the atmosphere. Now it's still really, really, really cold. It might be like minus 182 degrees Celsius as it leaves those vent ports. So it's still unbelievably cold air coming in contact with the humidity in the atmosphere. And that's why you're seeing that. Now, the reason for the flare stack over there on the left, that little fire that you see, you can't do that same thing for liquid methane. So you see a flare stack for liquid methane, you see it for liquid hydrogen. You do not see it for Kerolox or hypergolic rockets. Kerolox or RP-1, the kerosene can actually just sit at room temperature. It doesn't boil off. It's jet fuel. It's kerosene, basically. And so it can sit comfortably at room temperature. It won't boil off from sitting out in the, humid atmosphere and just in the, we'll say 20 degrees Celsius or, what is it, 70 degree-ish Fahrenheit temperature that is Florida. So Keralox doesn't boil off, but methane, liquid methane, and liquid hydrogen are both cryogenic propellants as well. Liquid methane is a lot closer. I don't remember what the temperature. I think boiling point is something like 160 degrees Celsius, minus 160 degrees Celsius, sorry. And liquid hydrogen's way down there. It's like minus 270. I have these charts like all over the place. Where are my charts? Someone give me my charts. But we use that chart often because it's talked about quite often. So anyway, the point, sorry, I'm rambling a lot because we have a lot of time. The point with liquid methane is that you can't have it just, vent off of the rocket. You can't do what you see the rocket doing now, venting liquid oxygen. You can't do that with liquid methane. You would risk a detonation. You'd risk there being, gaseous methane coming in contact with gaseous oxygen, and having a small source of ignition would just boom, could potentially create a very bad detonation. So instead, when boil off happens for methane, they pipe it away from the launch pad and send it out of a flare stack, and then have an igniter at the top of that flare stack. So again, so you still don't get those pools of methane. You don't want those gaseous pools of methane to gather and potentially detonate. So they intentionally light it and let it continually burn off. And that's how you prevent any kind of catastrophe from happening. So you still see like SLS had a flare stack. Delta IV Heavy has a flare stack. The Space Shuttle had a flare stack. Starship used to. Now they actually just recondense methane, pump it back into the ground supply systems. That's another option. Just takes more infrastructure, and it's a little bit more of an investment to do that, but likely worth it. So there we go. That's my flare stack little talk here. Hopefully I didn't ramble on so long that you guys are all asleep at this point. All right. Let's see here. From Hacker Twins. Why do people keep calling this the first 3D printed rocket when only 80% is 3D printed? That's an insane amount. Rocket Lab uses 3D printed Rutherford engines and maybe some other components, but the bulk majority of that rocket is carbon fiber and then other, aluminum and traditionally manufactured bits of the rocket. I'll bet by mass, Rocket Lab's Electron, especially because it has batteries that are not 3D printed, I'll bet you the mass of 3D printed parts on even the Electron is probably like 5%, maybe 10%. So this is quite literally the tanks are 3D printed. Like that's, when we say it's a 3D printed rocket, it's because the rocket is 3D printed. Like they literally have this machine that prints the rocket. Like it's insane. It's ridiculous. It's never been done before. Electron, obviously, that's not to say it's not. Oh, we are in a hold. Let's see if I can put it in hold.
Placed another hold on the T clock at T minus 24 minutes. We do need additional time for propellant conditioning. We're going to stand by for additional updates, and I'll send that to you as soon as I have them.
Alrighty. No big deal. They have a 3-hour launch window today, so not too worried about that. Not too worried about that. Okay, let me get back to here to answer some questions. That's also why I didn't want to start this launch too early, or this live stream too early. I was really trying to push it back, as we had a little scrub at the beginning, because this is the first launch ever for this company. There's a real good chance that we see a handful of scrubs and stuff today, so let me move this down just a touch more, by the way. Let me see if that works. Let's go a little more. There we go, just so they're not totally overlaying. So that's why I was thinking, this is the first time this company is launching. So let's not get on here too early. We might be waiting. And there's a real decent chance that it doesn't launch today at all. This is the first launch after all. It says that, there's a decent chance they might find some issue during fuel up. They might be experiencing an issue, with an engine sensor. They have 9 of these engines on the first stage of the Aeon engine. So there's a decent chance that one of them doesn't seem happy, or they even go for ignition and light the engines, and the computer goes, not today. Don't be surprised if that happens. Again, developmental rocket, first rocket launch attempt ever for this company. So I've got my patience pants on. I'm not going to be too upset if nothing happens today. It's still good data for the team, and it's still good learning lesson on how to move forward for them from then on. Anyway, So we'll see. You know, I've still got my fingers crossed here, and I'm still hoping for a nice clean launch today. But we have to wait and see. So what was I going to say on that note? There was something I was going to tell you guys. Oh yeah, hopefully it doesn't reset to too much longer. Like I said, I have a really busy week coming up. I might be able to do a couple days next week to watch this with you guys, but if I have tomorrow same time, I could probably still stream. But if it goes beyond tomorrow, I probably will be tied up. So hopefully, I'm really hoping it takes off today or tomorrow, because I really want to see this and I want to hang out with you guys. All right, let's keep answering some questions from Daniel's Weather Space Station. 6 months of membership, thank you so much. That really means a lot. Tim, how close is Luna to being 99.9% reliable and not cutting out right at liftoff of a rocket? Guess we'll find out during Starship coverage. So the problem there wasn't Luna. And it wasn't even, the worst thing about that, it wasn't our internet. It wasn't like the encoder on our end of things. That was so frustrating because we had this encoder, a 4K encoder, and that actually sends stuff up to the cloud, and then the cloud sends it to YouTube. And there's things called a variable bit rate and a constant bit rate, CBR versus VBR. We were telling it to be a constant bit rate. So just, hey, 20 megabits per second or whatever we were saying, 25 or 30 or whatever, just send that. And we were getting rock solid data up to the cloud. The problem was the handoff from that little cloud service that we had to use for this encoder to YouTube. My theory, they still haven't like really explained this, which is why we moved on to a different encoder. My theory is when you're sitting here like this, look at this frame right now. How many pixels are actually moving right now? There's not many. Like the little, condensation clouds, you got the flare stack. Most of the image is more or less relatively static. So the compression algorithms can sit there and kind of just do blocks and like, it doesn't have to do much work. This can be a very low bitrate stream right now. At liftoff, all of a sudden you have most of your pixels changing. Like most of your pixels, like that confetti problem. Have you ever seen like where, confetti or tons of moving objects makes an encoder go crazy because all of a sudden like, oh, I can't just dumb this all these pixels down. I have to actively, change every pixel, and that's going to take up data. So all of a sudden our bandwidth was still constant to the cloud, but then the cloud service threw like 100 or 200 megabits per second at YouTube, and YouTube hates that. YouTube says like, don't send us more than 40 or something. I don't remember what the number is, 40 or 50 megabits per second. Like we can't handle that really. So I think that was the problem, is that the handoff was actually sending too much data to YouTube, and we didn't have any control of that. And that was something we were complaining about with customer service, and they just didn't reply. So we have moved on from Teradek, and we are now using a live view unit. It has, it's rock solid, and I'm very confident. I am very confident in that because we spent so much money on it. And so we're spending so much money on it each month, even though we're not using it right now. But that is a bonded service. We have 6 SIM cards, and you can use 2 Ethernet ports on it and Wi-Fi as well. So we're really, really thinking that this thing, bonded solution, is going to be fantastic. Mars is harder to stream from, though. Our data out there is abysmal. Even though we're using Starlink, we're using Spectrum, we're using 6 SIM cards, it's still abysmal. So we are streaming in 1080 at Mars. We're going to try to just have a nice low latency live stream. Nice clean live stream. It'll be great. Our cameras are awesome. 1080 still looks fantastic. High bitrate 1080, low latency. It'll be great. I think of all the streams available, I think we'll have the quickest to air. So from photons happening in real life to your eyeballs, I think we're going to be pretty low, like 5 seconds or so. So we'll be fast, which I'm excited about. So yeah, if you want to know what happens seconds ahead of anybody else, I guess you have to tune into our stream. So that's how I think we're going to be reliable, because we've spent way too much time and money on it to not be. Shout out to Pete for inspiring me to go watch the Falcon Heavy return to launch site. He asks, with the news about John McFall, will there be more of a push with disabilities to become an astronaut, such an inspiration? I don't know what the news is with John McFall. Or is he the ESA astronaut? Yep, the ESA astronaut with a prosthetic limb. Absolutely. I mean, I very much assume that once there's someone with a prosthetic limb in space, there'll be a whole generation of kids that grow up realizing like, oh, cool, I can do anything, which is absolutely going to be amazing. So yeah, thank you so much for that, Broomy. I appreciate it. Macbeth, how do we know the actual speed of a rocket? Is it with Doppler effect from radio waves and telemetry? It's not like there's a speedometer at the nose. So yeah, back in the day, I'm pretty sure most telemetry was done using the Doppler effect. And in space navigation, it's pretty much all Doppler effect on radio waves, like exactly like you said, which becomes hard when you're perpendicular. So, radio waves would propagate from a source and go out and back. So if something's moving directly away from you or directly towards you, it's extremely accurate. If you have something moving like left to right, it's harder to do. Now, if you have multiple sources there, you can triangulate position and telemetry from that. Nowadays, we can use GPS, which is locked. You have to, you have to get all that certified nowadays, because otherwise it could be, ballistic missiles. So, but GPS is something that is utilized as well for speed and telemetry. Accelerometers can also very accurately gauge your speed just by continually adding up how much acceleration per second. So yeah, that's there's a handful of ways. I think there still are like barometers and maybe even piezo tubes and like things like that. There might be stuff like that. I don't actually know each rocket, and a lot of that stuff is. I should probably do a deep dive on. I actually have a lot of people asking me how do rockets navigate, and that's one of those things that I'm like so nervous to touch. I don't want to touch it because it's a topic that I know nothing about, which is probably exactly why I should touch it. And I'm just nervous it's gonna be such a rabbit hole, such a rabbit hole. All right, let's see. This is from Jello Mob. What do you think of the Dynetics Alpaca lunar lander? Do you think it or Blue Origin's lander will ever be used for Artemis moon missions? Let me think. So Dynetics, let me double check. That's the one that's. But the problem with Dynetics lander, so I actually have a video about this too. It was my second video of kind of Starship versus. This one was like Saturn V and Apollo program versus the Artemis program and SLS. And we do talk about some of the landers in that. I really liked Dynetics lander, but apparently it didn't even have enough delta V to properly land on the moon and fulfill the missions. Those drop tanks weren't enough. So hard to say. I liked that design though. I like the low slung. It's almost like a Dachshund version of a lunar lander. Like the engines, the passengers in the crew compartment is in between the two tanks, the four tanks technically, and all of the landing engines. So you open the door and you only walk down like 2 steps and you're on the surface of the moon, as opposed to like the Blue Origin lunar lander is like you climb like 20 rungs of a ladder. It's a much larger egress and potentially more dangerous egress situation. So let's see. I do think there's a lot of talk of a second. Of NASA procuring a second lunar lander option, which I think would be great. I love that idea. Obviously, I'm a fan of Starship, as I think a lot of us are, but I'm also a fan of options and other vehicles and other companies. So obviously, I would be very excited to see a second option on the table as well. I think that's never a bad thing, assuming that funding maintains strong enough for both options. I do want to point out that you'll see ice occasionally falling off. Again, we kind of talked about how this rocket is filled up with liquid cryogenic propellants, with it being methalox, so liquid methane, liquid oxygen. You'll notice occasionally little bits of just chunks of ice, just like this is the same type of thing as, a freezer will get ice, especially like a deep freeze will get a lot of ice on the walls and all that stuff. And it's the same thing. It's just condensation in the air, humidity in the air coming in contact with the tank, freezing solid into a layer of ice. And occasionally some of that ice will fall off. Yeah. This is the other thing. Yeah. From Artelgus. Sorry if I'm totally ruined that. With 3D printing, you can put a tank inside a tank inside a tank, and all the pipes can be integrated into tanks. That's true. There's a lot of options with 3D printing that you just can't do physically or easily can't do with traditionally manufactured parts. Oh. We might be in a new 51. I'm guessing they're going for. Oh no, that'd be like 40. I'm guessing they're gonna end up somewhere around 140 right now. Wait, 2:40 their time, and they have until what, 4 o'clock? While this is just on hold, I'm gonna check our fact sheet here with you guys. So they have from 1 until 4 Eastern. And so,
Taking it back once more, we just coordinated for a new T0 time with the range. Our new T0 time is now 14:40 Eastern. That is 2:40 p.m. Eastern. We're going to allow a little bit more time for propellant conditioning. As some of you may know, this is not at all unusual for a first launch. This is perfectly expected since we want.
Let's make sure that wasn't on my end. Let's just do this. Sometimes, hopefully that will.
Perfectly expected since we want all systems to be as perfect as possible before we do this.
Yep, I agree with that. I want these to be perfect as possible for the first launch attempt, just making sure we're as live as we can be. I'm gonna do that little trick though where you go. Something is going crazy right now. Hang on. 1.5, go like this. Where's the live button? Click live. That'll make sure we actually get caught up and stay caught up. And it'll put us deep into the future, which is always very exciting. All right, let's see here. Why didn't... Actually, you know what? I'm going to take a... I forgot to grab my water bottle, so I'm going to get some water, and I'll be right back down in literally just like a minute. I'm going to leave you guys just with the rocket hanging out. Unfortunately, they do have music playing, so it'll probably be a copyright strike. So it'll be kind of awkwardly quiet, I guess. I'm sorry. I love you still. I'll be right back. Did you miss me? Did I miss anything? The rocket's still there. That's fantastic news. Ooh, yeah, I forgot we had that little stinger. I can hide that again. Oh, Mary Liz already did. Ha ha ha. That's so cool. Anyway, hi. What did I miss? Anything? Looks like still doing the same thing. All right. Andrew the astronaut, why didn't other companies like SpaceX or Blue Origin or ULA 3D print more parts if it has a long-term benefit? I think it was just considered like, I mean, it's kind of one of those why. Why would you, we can traditionally manufacture a rocket no problem. Again, take a Falcon 9, for example, more or less just take sheets of metal, roll them, and do a big stir weld down the middle, and you end up with a rocket. I just think it hadn't been questioned. Like, why would we change that? That works. I mean, there's still a lot of people saying, why would you do this? Well, what is the point? That's literally probably the number one question today is why are they 3D printing the rocket? But I think long term, I don't know. We'll see that they believe long term that they can make iterations and changes to their vehicle and improvements a lot quicker than anybody else. I hope so. I hope that's exactly the case, and I think that'll be very, very cool. So we will see. We will see. All right, Michael Storm Global Overlanding Adventures. Thank you so much for becoming a member. Same with Sean Fullard. Very much appreciate that. Let's see here. This is Air 4563. Relativity claims Terran R is targeting medium-heavy launch market. What types of missions do you think fall into this category? At this point, the vast majority of launches are definitely in that medium-heavy launch market. Falcon 9 is kind of proving that they're just so booked already, and they're flying so frequently. Now, granted, Falcon 9 is launching mostly their own payloads, and their payloads are designed specifically around the performance and the capabilities of the Falcon 9. So not only mass considerations, but also volumetric considerations. It's beautiful vertical integration between the customer or the end user, in this case Starlink, and the launch provider, in this case SpaceX, which are both, SpaceX and SpaceX. So, but at the same time, even for the majority of satellites today, geostationary payloads and things like that, you need a medium to heavy class launcher to fulfill, and DoD, Department of Defense contracts, Space Force missions, things like that. Like you got to kind of be up in that upper medium class, it seems like. I think about, at least a good 8 tons to low Earth orbit. I think medium class technically starts at 2 tons. I think you got to be hitting that 8 to 15 ton class really these days to fulfill the majority of missions. I think that's exactly where Rocket Lab ended up with Neutron, is reusable first stage. I think they're quoting 8 tons. If they expend the first stage, we're looking at 15 tons. And that gives them the option. Of course, they wouldn't want to expend a stage, but if it's $100 million more contract or something, so let's say they're selling. I'm making up numbers. Let's say they sell service for normally $60 million, and they could sell a 16 ton to low Earth orbit service for $120 million or something. As long as it's profitable, then that's an option that they do have. As do, any reusable rocket company. If you just throw it away, of course, you're going to get more performance and can sell more of a service, but you're losing out on hardware. Thank you so much to Leandro Kira. Very much appreciate that. Random Joe 69, just sticking this here to do my little but fair share to support Tim and team. Keep it up, guys. Your contribution to space knowledge is invaluable. Thank you so much. I really, really appreciate that. Again, I know I've said it 50 times because it's very topical. I'm literally I'm having a hard time even talking because I'm still thinking about all the things I have to do to get the how to start a rocket engine video up online by tomorrow morning. So I'm still just very much in that mindset. So sorry if I'm a broken record about it, but I think you guys are going to absolutely love that video. It teaches, if you've seen it, if you're a Patreon supporter or a Discord member or YouTube member and you've seen the video, leave a review right now. Let me know if it was helpful, if you learned something, what you thought, and let's see what people say. And we'll try to pull up a review of someone that's watched it already and let you guys know. I'm curious. Obviously, I've read all the feedback on our review links and stuff like that. But, yeah. Let us keep going. All right. So Rigel wants to know, which is more quick to produce, a 3D printed rocket or an ordinary rocket? I don't think we really have the metrics. I think Relativity is claiming 4 months, I think, from start of print to end of the print for a full rocket. Then of course there's still integrations and production to do from there. That's slower than what SpaceX can build a normal rocket right now. But again, the changes is when you don't have to change out tooling, especially carbon fiber is maybe one of the worst in that sense. If you change a design with carbon fiber, you have to change all your tooling. And to some extent, most metal. You're not just going to physically bend metal like they do. Well, unless you're Starship, then yeah, you're just kind of going to be like, whatever, we'll just cut this and weld it. Who cares? They have a little bit different philosophy out there. But in general, 3D printing has the ability to iterate very quickly and make changes very quickly. Like I said, they might realize that, hey, this is taking up a lot of time on our printers and a lot of wear and tear and material, blah, 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 to 3D print the actual tanks. Let's keep all of the other components 3D printed and just print and just do a traditionally manufactured tank someday if they want to. They have that option. They have that ability. Again, for now, they're really, I think, just trying to demonstrate the full capabilities and see what works and what doesn't, and use that as a starting point. Almost let's see how much we can do and then almost walked back from there. I think that's, that way they know. Tori Uno, thank you so much for becoming a member. Let's see. Why did their live stream just end? Their live stream didn't end, I don't think, hopefully. Let's see. This is from D&D Doggo. It's crazy that I've not really heard of this until Lex Friedman's podcast with you, and now I'm realizing the space industry is absolutely huge already. I never expected this amount of companies. Yeah, I did a video that not a lot of people watched, and you probably should. Actually, why didn't I think about dropping... I might have to take a break and share this video right now. If you go to a little website, youtube.com, and type in small sat launchers, you will see something very fun called Who Will Be the King of Small Sat Launcher. And we do compare Astra's rocket, which they gave me the wrong numbers. Even though I reached out to them and said, hey, can you double check your figures here? They gave me completely false numbers. So I'm not very happy about that. Electron, Launcher 1 from Virgin Orbit. We have RS1 from ABL. We have Alpha with their... of course, with their, or Firefly with their Alpha rocket. I was like, why can't I say this? Terran 1 from Relativity, and we even compared it to the OG, the Falcon 1 from SpaceX. And we show all the different things. Oh yeah, SpaceX's rocket was 450 kilograms, the Falcon 1. So, and this is, I think they're quoting now 1,250 kilograms to orbit. So they've, a lot of these companies, it's funny seeing this chart now. A lot of these companies have changed these numbers around here and there. There we go. Yep, Stanley, Casper Stanley has a chart. I need to share this. It is still a valuable video, but and it is already a year ago. I think it came out almost 2 years ago, May of 2021. So already 2 years old. And when I did this video, I think the only ones that had launched were Astra, Rocket Lab. I don't know if Virgin Orbit had launched at the time. That's crazy. Now all of these, this is the last one on this chart to make a launch attempt. And now the only ones that haven't made it to orbit are, as of this video, of course, is Terran 1 because it's sitting on the launch pad, and RS1 from ABL. Yeah. Trevor, that's, Trevor says, and I bet 0 of these are flying in 5 years. Interesting. I mean, I know it's a pessimistic, Trevor's kind of more a pessimist on lots of things, but I think there's some truth. I think in 5 years still, yeah. I think still in 5 years, these will be flying. It's a few of these rockets will still be flying, but I think by this point, you're right. I think a lot of these companies will have matured into different versions of these rockets, more capable versions, maybe beyond the small sat launch rocket industry. But Firefly is already working on not to say any of these companies won't exist. He's saying none of these rockets will exist. And I definitely already Rocket 1 by Astra, that's done. Electron's still got some life in it, I think. I don't know. It very well could still be flying in 5 years. Launcher 1, we'll have to see what Virgin Orbit does. They might have to make some upgrades to it. We might see a totally different version. RS1, see most of them... Hold on.
Back at T-minus 38 minutes, we did set back the clock and coordinated with the range for a new T0 time of 14:40 Eastern. That is 2:40 p.m. Eastern. We did add this time to allow us to continue our propellant conditioning. We'll continue to provide you updates as we get them.
All right, yep. That's what we figured. So, back to talking about these. So, I mean, a lot of them are developmental. Again, Terran 1 is developmental. A lot of these companies are treating these small launchers in the same way that SpaceX treated Falcon 1. Like, hey, let's fly it, prove our company, prove we can do avionics and, guidance in avionics and operations and blah, blah, blah at a smaller scale. And as soon as we can, ramp up into a more competitive marketplace. And I think that's exactly what's going to happen. We're seeing that already. Of course, Rocket Lab's already, working on Neutron. We see even Firefly already working on their 2nd generation rocket. We know that these guys, Relativity, are already working on Terran R. I mean, Astra's already working on their next rocket. What is that, Rocket 4 now? I don't even remember what they're calling it these days. But everyone is already pretty much moving on from these rockets now. So that's actually a decent thing that maybe in 5 years from now, I'm curious. Someone make a calendar. Trevor, make a calendar note. on March 5th, 2028 and say, are the small sat rockets still flying? Because I'd be very curious. I think you might be right that none of these rockets on that chart will be flying. I think that a handful of the companies, most of the companies will still be around. Handful of them. I'd say half of those companies will still be around. But we'll see. All right, sorry, that was a long one. This is from Arca. Should there be a website like the travel websites, but for rideshare missions, which tells the capacity, cost, and other details of rockets of all companies all over the world? Somebody please ask Tim. Well, you did. You already did. Arca, we caught that. I actually believe there's already companies doing exactly this. And they're kind of becoming brokers. Spaceflight is one of them. And I think they're doing exactly this. They're constantly negotiating and trying to figure out deals and arrangements for other companies. So between the launch provider and the customer. So there's already services like that. I don't know if they're public because it's not a, I think people are kind of holding their cards close to their chest still. Because at this point with a lot of rocket companies, if they have the ability to just barely undercut another company and maximize their profit, they're not going to put their bottom dollar out there for display. Like, well, this rocket. Well, here's the other thing. Companies, they have to bake in as much profit as they can because a launch scrub costs a lot of money and the customer does not pay for that. A customer pays for the service. So a launch scrub, say you have just a bad luck string of bad weather or, a faulty instrument or something, and say you have like 7 attempts in a row, that could almost bankrupt a small company. So they need to bake in as much profit as they can. So you can't just have people out there going, all right, our rocket costs $3.6 million to make. Launching it costs $1.3 million. So let's sell our service for $6 million, and have very little, there's just not much area there. So instead they're going to try and be like, hey, that, what are you willing to pay for that? You got $9 million from them. We'll do it for $8.5 million, and that's just how this is going to go in the market for a little bit. So at least in my opinion. We already did one of these, Todd K. What's the update on the mission? The update, just pay attention to Starship progress, and as Starship progresses, so will our missions. Obviously, I'm not going to be flying on Starship until it's out of development, and until Jared Isaacman has flown on it for the 3rd Polaris mission. So pay attention to just the progress of Starship, and know that I'll be on it when it's ready, when it's done. Thank you very much from Kai. Good to be back, ? I got concerns. Oh, question. Good to be back. I got concerns about Starship's heat shield. Why can't they make large panels rather than small tiles? Not to mention the fact that the potential risk of potential ice hitting the heat shield during launch. So ice shouldn't be as big of a deal. I did a video about this on Starship. Like, why doesn't Starship have an abort system? Should it have an abort system? Ice isn't nearly as big of a deal with Starship. The reason it was such a bad, and foam strikes were a big deal on the space shuttle, is because the orbiter and its fragile heat shield was slung off the side of the external fuel tank, which had the ice and the foam. So that was in line, it was literally like in the falling path of ice. Whereas this is at the top of the rocket. Most of the ice will develop and gather on the shiny sides of the rocket. There's just not much ice that's going to trickle down over those heat shields. You'll notice that during testing, you don't see a ton of ice on the black sides. So I just don't think that's as big of a problem. But that being said, why are they small? I think they're small for manufacturability, replaceability, and being able to contour to all the different shapes. If they're small, they can just bloop, 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 bloop. And they're a lot more, they're not as bespoke. You don't have these large panels that, oh crap, well this one's now an edge and blah, blah, blah. You can make a bunch of cheap small ones. Also, there's something about the way that they're going to have the plasma flow between all the tiles. That shape helps mitigate some of the heat flux. I don't know. Yeah, I mean, the heat shield's definitely a pretty big topic still, and something very much up in the air. So we'll have to see how it performs, and we'll likely see iterations. It's SpaceX. They'll iterate. That's something that the space shuttle didn't have. They did iterate. The first space shuttle had, what was it? 28,000 tiles or something. They got it down to 24,000 by the end. So they did iterate a little bit, but generally the concept was the same. So I think that, yeah, we'll see them iterate and we'll see them make improvements. And for my sake, when flying on it, I sure hope that they have the heat shield figured out. All right, let's keep going here. Thank you so much to Sean for that tip. I appreciate that. Astronomy Live, how's it going? Thank you for providing the in-depth coverage we just don't get from Discovery and Friends anymore. Wish I could be at the launch today. I wish you could too. This would be a fun one to try to track. Good to hear from you. Thank you so much for all your amazing tracking work as well. Yay. But yeah, to that topic though, it does make me sad that like growing up, I didn't grow up with cable. And so I remember when I would get a hotel, like when we stay at a hotel, and I would get so excited to turn on National Geographic or Discovery Channel or History Channel because I'd be like, oh, there's something I can learn. And I was just really excited by that because the programming was, History Channel was sometimes boring for me, because it was like, in 1924, it was a little bit more traditional, like, documentary style. But now they've moved so far away from that. It's like, what's the point? They're just producing the same junk garbage that all of the other networks succumb to with reality TV. It's just really a shame. And it's funny because like there was an audience for that. They just, I don't know. It's too bad. So for me, like I said, my goal with my videos is always to make them literally as high a quality as I possibly can. You'll hopefully have seen an improvement in videos throughout the years as I just continue to, to hone in our team and make more of an investment in every single video. I know that like starting a rocket engine is not going to be a huge video. There's not going to be 20 million people that watch this video ever. So it wouldn't be enough to probably even consider being on, television on a traditional network. But I know that for the 1 million of you or whatever that are out there that will watch that video someday, hopefully it's a great value and maybe it opens up some, some new light bulbs in your head and lets you go, I get that now and understand this stuff better than ever before. That's the whole point. I have a lot more fun watching these things when I'm like, oh, I get this. I get it. It, to me, makes it a lot more fun to watch. Let's see here. Oh, this is Maddie Ice got my Falcon 9 model on my stoop today, and I'm excited to show it off. Thanks for being you. That is awesome. Congrats, and thank you so much for the support. I really appreciate that. This stupid little thing, honestly, has been again everydayastronaut.com/shop if you guys want to check out our highly detailed metal Falcon 9s. You probably can't even see it because it's out of focus. But these I'm really, really, really proud of these. The legs do fold up and everything. You can take these pistons out and the legs fold up. I'm really proud of these. They were a lot of work and just more work than I ever imagined, and just the production woes. I understand now why Elon says that prototyping is easy, production is hard, because even making something like this was really, really, really hard. Even, things like all the details, like, having it so the box looks nice. Allie Gravity Coats did an amazing job with this box. But even the cutouts, like having it, one of the iterations, the first one, like we didn't have a big track for the raceway, so it doesn't break on shipping. It didn't have thumb holes, so you had to like get a pencil or a screwdriver to get the legs out of the box. Just all of those little things that you don't think about when you're first producing something, and then how much work goes into making sure that it is right and that it's done well. And that it's up to the high quality standards that I have, because they're maybe a little ridiculous. And I'm sorry for all of you that are in the production process of not only videos, my website, and now producing Falcon 9 model rockets and soon other models. Because I'm a perfectionist. I want things to be done right. I want them to be done well, and I want it again to be the type of thing that I would buy myself. That's my whole thing, is like, I just want to make the things that I want. That's the whole idea behind like the merch store. Was when I was first started this channel, there was not much good space merch, I thought. I wanted to make shirts that I wanted to wear. Same with, everything. I'm still a big fan of Ollie's rockets that he has back here. Oh, sorry, I realize I still have a sound panel. I rearranged things around here, still in the middle of rearranging things. But I love Ollie's rockets. They're incredible. His Falcon 9 and Falcon Heavy and stuff. Unbelievable models, but low production rate. They're extremely fragile. Every time I ever physically have to move them, I'm crying and scared. Whoa, a lot of ice just fell off. But yeah, so that's just kind of my philosophy. Like, make the stuff that I want for myself. Anyway, long rant over. Everydayastronaut.com/shop. Thanks for the support. Love you guys. Eric Space, thank you for becoming a member. Much appreciated. This is Robert Thomas. Is it true they are using liquid natural gas? If so, will this really be the first methalox fueled rocket to orbit? Shouldn't that record be LNG contains C2H6? That's not pure CH4. I forget. Are they liquid natural gas? Can someone remind me? I don't remember if they are. Why am I blinking? I feel like they are liquid natural gas. Wait, 97% CH4 though. I would call that methane. I mean, obviously, liquefied natural gas, not liquid. Liquefied, oh yeah, well, liquefied natural gas. Yeah, so 97%, that's pretty pure methane. And of course, natural gas is mostly methane. So I don't know. I think it still would pretty well fall into methalox territory. Yeah, CH4. Yeah, CH4 is methane, but what was it? C2H6 is not pure CH4. Anyway, I bet getting rid of that 3% is quite expensive, says Juan in our Discord. I agree, and maybe there's just a trade-off. You know, there's everything in rocket launches is a compromise. It's like, do we remove that 3% impurity? Do we get an increase in performance? Blah blah blah. How much does that cost? What's the long-term benefit? And blah 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 blah. And yeah, 97 is probably good enough. I wish. Is there a way? Can I actually do a poll? Yeah, I am gonna do a poll. What model rocket should we build next? Space Shuttle and Buran, Saturn V, and N1. That's like the one that I want more than anything. Atlas, Mercury, Redstone, Atlas, Gemini. That barely fits. So Atlas, Gemini, sorry, I'm like kind of mixing a whole bunch. I was thinking like an old space. I don't know. Old space. Atlas, Gemini. No, Mercury, Gemini. Because that way it could include the Redstone. US old space. Old space. And then also Soyuz Proton would be another one. Those are probably the big ones. Obviously, there's ESA rockets, there's India, there's a lot of others, but I think I'm going to do this. All right, here we go. There's our poll. See it in the comments. Hopefully you guys are... Oh, no, I knew it. I shouldn't have done this. I shouldn't have done this because Saturn V and N1 is going to be the most popular for sure, and that would be huge. Do you know how big that would be compared to... If this is what? 70 centimeters. Oh.
T-minus 23 minutes. If you recall, we did set the T-clock back a little bit in order to allow for propellant conditioning. You might also be able to see that the clouds are coming in. Our team is keeping a close eye on the weather right now just because we want the maximum visibility that we can get for this historic first launch. We'll keep you updated along the way.
Okay, thank you for that update. We definitely appreciate those kind of updates. I remember when I was doing streams for Firefly, I wanted to get updates. You guys wanted updates. Everybody wanted updates. It's nice to get even a no update is a nice update. So I definitely appreciate that communication for sure. Okay, so this is what, 70 centimeters tall. So not even a meter. And of course, the Saturn V would be what, 111 centimeters.
Clay Walker in Mission Control. Let's listen in for the next few minutes.
Update. Hopefully they give us that update. They said stand by for one. Great, I let music play again. Here comes a copyright strike. Yeah, they aren't doing anything. Okay, anyway. Current poll states Space Shuttle Buran at 30%. Saturn V, and I almost am choking to death. Do you know how heavy? We'd have to do that out of, it'd have to be plastic. This one's already too heavy. I think this rocket is like 2 kilograms or over a kilogram for sure. It's heavy, like hilariously heavy. I'll bet in total, I think shipping weight's probably like 1.5 kilograms or something. So over 3 pounds. If we scale that up to a Saturn V and an N1, I'm like choking every time I say N1, because it's so big. It's 18 meters wide. That'd be 18 centimeters wide. That's like, oh God, good thing this is metal. That's like this wide, I think. Let me think about that. 70, 45, 25. Okay, so a little bit smaller than this, like about that wide. I mean, that'd be absolutely crazy. Here we go. This might be the briefing. The music just ended. The music stopped. Oh wait, that's my headphones. Probably. Classic. Still nothing. Okay, still nothing yet. So, yeah, that would be really big. We'd have to make that stuff out of plastic just to make it so you could ship it. I mean, think about how big those boxes would be. It'd be like the size of a vacuum cleaner. Maybe that's what I should do. A Saturn V vacuum cleaner. No, N1 vacuum cleaner, Saturn V leaf blower. No. All right, so we had 2,500 votes. Last chance to get your vote in. Last chance to get your vote in. That would be huge, honestly. And eventually Starship would come later for sure once, Starship and even like Falcon Heavy and stuff. Once we have more of a collection and once Starship stops iterating so much, we would probably love to, I'd love to make a Starship model too, so. If a vacuum exists. All right. The poll is right here on YouTube in the comment section. Hopefully you guys see that. Sea Dragon. Yeah, that's what we'll do. We'll do Sea Dragon next. It won't even fit in most people's houses. All right. Well, let's get back to answering questions. I'll keep that poll up for fun. All right. So Jim Moore, has NASA ever built a rocket, though? From what I gather, it's companies like Boeing, Thiokol, Lockheed Martin, Grumman, who built, yes, that's 100% correct. But the design and the operations of the rocket are NASA. So that's, yes, they're always going to use contractors to build anything. And that's actually half the problem, too. It's like they do the design work and the engineering and then hire someone, and typically at a cost-plus contract.
But no-go polls to occur in approximately 3 minutes. While we wait, let's talk about the nose cone that we have today.
So we don't have a customer payload on board, but we do have a memento inside of our nose cone. We have included our first ever 3D printed piece from our Stargate printer. And of course, it was a failed print since no one had ever done it before. As you see on your screen, that is our nose cone memento. That piece is 6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with GLHF, good luck, have fun, and our mitosis logo to commemorate this maiden launch.
From our very first failed print 7 years ago, Relativity's team relentlessly overcame thousands of challenges against all odds to get to today, our first 3D printed rocket launch. Like the first print, Terran 1 is the first step of many towards making humanity a multi-planetary species. As a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle. In just a few minutes, the launch director is going to poll the teams for launch, so let's listen in.
Yes, one of my favorite things. I love this. I wish that SpaceX did this still. Oh, old school poll. Like, give me that old school poll. I want that, especially for like when they do Starship. I'd love. It's funny they mentioned the clouds rolling in. To me, it looks like it's just been clearing out. We couldn't even see blue skies at the beginning. Now, of course, a lot of this could be just which direction the cloud cover is and which direction these cameras are facing. But I mean, to me, it's looked like it's clearing up. So hopefully they get good news. I can't wait. All right, let's answer a few more questions while we're waiting for that go, no-go poll. Which music just stopped? Is that a good sign? Nope, just started over. From Don Page. Hi, Tim. Relatively new fan. Saw you on Lex Friedman's podcast. I love your content and how brilliantly you explain everything. Keep up the great work. And here's a small donation to keep going. Well, thank you very much, Don. I appreciate that. I don't think I'm best at just describing things with my voice, which is why it's so hard for me with Lex. He'd ask me a question like, explain the aerospike. And I'm like, I have a 1 hour long video that has like an insane amount of animations to explain the aerospike. And you want me just to talk about it? Like, it was hilarious for me. But I really, really, really enjoyed that podcast. So thank you for watching. Hopefully you've now had a chance to catch up on some of the produced videos that I'm a lot more proud of those than I am just my lack of ability to talk about rockets that are on a launch pad or something. Macon Patton, thank you so much for the tip. I really appreciate that. John Jameson, does Relativity use supercooled oxygen like SpaceX? Sorry, I've had this cough for like 4 weeks now. Tested. I don't have COVID. I don't know. They haven't actually mentioned for sure if they super chill their oxygen. I actually don't know any other companies that have gone into and looked into super chilling oxygen. That's where you chill it closer down to its freezing point. So you can get a little bit more density out of the propellant. I remember ULA, Troy Bruno was hesitant and said like, well, yeah, good luck with that. We've tried super chilling propellants. It wasn't really worth it for us. So I don't know if that's, now a bygone, if people are willing, like, hey, SpaceX super chills O2. Why don't we try super chilling oxygen?
FTS go. RF. RF go. RF go. GNC. GNC go.
GNC go. We still have music in the background.
Flight software. Flight software go. Flight software go. Prop 1. Prop 1 go. Prop 1 go. Prop 2.
Prop 2 go.
Prop 2 go. Fluids 1.
Fluids 1 go.
Fluids 1 go. Fluids 2.
Fluids 2 go.
Fluids 2 go. Loads.
Loads go.
Loads go. Rock. Ranges grow. OSM.
OSMs go.
OSMs go. RC. RC go. Vehicle.
Vehicles go.
Vehicles go. CE.
CEs go.
Cs go. LC.
LC go.
All parties have reported go for launch countdown.
Yes.
Once the T-clock begins, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that the OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and the RC on the primary net.
LCCE on Bravo. Can we open stage 1 fuel bleeds, please? Copy. Opening stage 1 fuel bleeds.
GCVC, please limit comms channels to Alpha, Bravo, Charlie, and countdown unless directed by LC or LD.
Support room, this is vehicle on LV.
There we go. I was going to say, we probably aren't supposed to be hearing that anymore. Because once they get out of that go, no-go poll, they get back into vehicle operations. And that's the stuff that starts to get proprietary.
You just heard our launch director complete the go, no-go polling with our mission control team. All systems, as you heard, are currently healthy, so as of now, we're able to proceed with our scheduled launch time in about 12 minutes.
Throughout today's live stream, you've been hearing callouts for mission control. Let's take a moment to introduce you to our mission control team. Clay Walker, launch director. John Wiswall, launch conductor. James Harris, chief engineer. Elijah Escobedo and Zoe Dickert on vehicle controls. Brian Batters, ground control. Bill Stack, ground. Joy Mosdell, range control. There are a few notable members of leadership supporting today's launch who are also here at Launch Control. This includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer, who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of Cape Operations, Pat Svatek. These are among many, many others who are making today's launch happen.
Fantastic.
For those of you that are just tuning in, you can see Terran 1 on the pad. This rocket is 85% 3D printed by mass. It is 110 feet tall and 7.5 feet in diameter. Stage 1 has 9 Aeon 1 engines, and our second stage has an Aeon vacuum engine. These engines are also 3D printed using powder bed fusion. We're going to go ahead and take a moment to pause and stay tuned as we wait on the launch countdown.
Hopefully not hold and stay tuned, but we will see. Everything was go a second ago, so unless we hear a... I'm guessing just their commentary is just going to hold for a little bit because they might be ahead of schedule on there. So lots of times hosts and stuff, you'll have like a here, read this at this time, here, read this at this time, read this at this time. As you maybe have noticed with, SpaceX and other launch providers, it's normal. So there's a chance that they're just like, all right, well, now we wait until we get closer to T0. And that's why when we answer more questions. This is from Michael Wagner. Yes, this could be the first Methalox-powered rocket to orbit.
Here, our countdown sequence will begin in T-minus 10 minutes, so just 30 seconds away.
Sweet. Let's see here. From Christian, thank you so much. Thank you for celebrating 6 months of membership and for your continued support. Much, much appreciated. This is a great question from Pierre. So, liquid oxygen is arguably by far the best oxidizer. Oxygen is obviously an oxidizer. You want it to be rich in... Oh, I just heard a little countdown sequence has started. So that's good. Oxygen, you need to liquefy it in order to make it dense enough to fit inside the tanks.
T-minus 9 minutes and 40 seconds. In the upcoming minutes, you're going to hear several call-outs from Mission Control as we go through the final pre-launch procedural steps, including the priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, and we're currently proceeding with our scheduled launch time.
Heck yeah, you are. This is amazing. They're going for it on their first launch attempt ever. T-minus 9 minutes. I hope this thing just takes off today. That'd be so awesome. Friendly reminder, too, they mentioned on the webcast and in their press.
For a call out in the next 30 seconds, that stage 1 is transitioning to helium.
So they mentioned a few times here that, this is their first launch attempt. With any first launch attempts, and I said this over and over, with Firefly's launch attempt, they're just looking to make progress here. Orbit would be like an absolute home run. That's never really been done. We can say it's never been done with a liquid class privately developed rocket, or liquid privately developed rocket, orbital rocket before, making it to orbit on the first attempt. And, that'd be an absolute home run. Anything short of that is still incredibly valuable data. They even said if they make it through max Q, they're going to be really, that would be amazing, getting through maximum aerodynamic pressure, because that's when they can prove out the structural support, the structural rigidity, and prove out just the, what am I looking for? Structural...
Stage 1 pneumatics have transitioned to helium.
There we go, stage 1 pneumatics have transitioned to helium. That's when they would prove out the...
There you go. That means we're pressurizing the propellant tanks to flight pressures.
For engine chill.
Prove out the of the structure, certifying the 3D printed
We'll be
structure. I can't
charging
think
the
of that
stage
word.
2 igniters to flight targets in just about 10 seconds.
So these two are Pierre and Crassy had, what does propellant conditioning mean? Cool it off. So yes, you need to keep it you need all of the fuel inside the tanks to be liquid. And of course, if it is a liquid, it'll be sitting at the bottom of the tank compared to a gaseous version of that. So as it boils off, the bubbles would rise to the top, and they need to be vented out. That's again what we see, liquid oxygen boiling off kind of at the inner stage there of the rocket, between the first and second stage. But it all needs to be cold to be condensed down into a liquid. Otherwise the tanks would need to be 1,000 times larger. As you can imagine, holding 1,000 times more volume of something is not going to be lighter.
We are now getting into the business end of today's countdown.
Pressing stage 2 igniter to flight target.
Arwa, let's go ahead and walk through the launch timeline.
Yeah, sure. At T-minus 3 minutes, the transporter erector will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. At T-minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. We then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operation safety manager. At T-minus 6 seconds, we'll have ignition of those 9 beautiful 3D printed AON-1 engines, so you'll see the flames beneath the rocket at that point. And at T0, we will have liftoff. Shortly after that, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly vertical. At T plus 12 seconds, we'll begin our pitch over program, and at T plus 80 seconds is that important milestone of max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we'll have main engine cutoff, or MECO, where the stage 1 engines will shut off, followed shortly by stage separation and the AON vacuum engine igniting. Second stage will burn for a little under 5 minutes. And then at approximately T plus 463 seconds, we'll have second engine cutoff, or SECO. As a reminder, we do not have a fairing or any payload deployments for this first launch. With that, we'll go ahead and wait and stay tuned with Mission Control.
And once again, we are so honored to be hosting this launch with you all today. I'm Arwa Tizani-Kelly, Technical Program Manager for Test and Launch at Relativity Space.
And I'm Rachelle Aniceto, Chief of Staff for the Vehicle Architecture and Technology team.
And we are now less than 5 minutes away from watching the world's first 3D printed rocket launch.
Nothing beats the hype.
Stage 1 igniters priming in.
Of a first launch. Oh, yes.
We're currently priming the igniters with gaseous oxygen and gaseous hydrogen. Our ignition system uses these propellants flowing across a glow plug.
They use a glow plug. We talk about that in my video. Their igniters are
Stage
glow
2 is
plug.
on internal power.
Very much like a
And
diesel
you just saw the transporter erector cradle disengage.
The cradle's disengaged.
There we go. The cradle arm slowly started releasing stage 2 at the top there so that the strong back can retract, and we confirm that stage 2 is now on internal power.
Yeah, so glow plug, no T-tap. That's right. They're just going to use a glow plug for ignition. T-minus 3 minutes coming up. This is crazy. We have a lot more questions to answer from you guys, so I will be answering those as soon as I can.
Stage 1 is on internal power.
Really listen in, and after the launch, I'll stick around for a while and answer questions that we have. So, so if you don't have your question answered, don't worry. I see
Stage
them.
1 TVC checkout complete.
We have a wonderful TVC. That's thrust vector control. So
We just completed stage 1 TVC checkouts. That means that we performed the final thrust vector control health checks on both stages before liftoff. We'll be doing stage 2, or rather completing stage 2, within the next 10 seconds.
Oh man.
Stage 2 TVC checkouts.
guys. So I'll try and remain quieter now that we're getting into the final preparations here of this launch. But like I said, I'll be around at the end to answer questions. However, look at that. Thermally conditioning the engines.
Next up, we'll be retracting the strong back, and then our range coordinator will ask the range for their status one last time.
I might have to use some of this footage in our how to start a rocket engine video. Whew. Heart rate check, everybody. Heart rate check. T-minus 90 seconds coming up.
Rock report range status.
Range green.
And that was confirmation that the range is green for launch. We are almost a minute away.
Announcement on countdown net. This is the LD. We are holding at T-minus 70 seconds prior to terminal count to address issue.
Hold.
All right, you heard Clay Walker, our launch director there. We are holding at
Strong
T-minus
back retracting.
69 seconds to address an issue. We are, however, at the same time retracting our strong back. That black truss structure there is the strong back. It'll retract just a few degrees to prepare for umbilical separation. We'll stand by for further updates from Mission Control, and we'll update you on the hold.
Again, this is not to be unexpected for a first launch. Hopefully, I'm nervous. We were right at that. They said, what was it? At T-minus 70 seconds. There's actually a chance that they said in the launch conductor, they said any hold will actually run up till T-minus 70 seconds, at which point it'll scrub. So they may have called a hold earlier on, and they just let it go through the rest of the motions until it gets down into that very last little terminal count. So now, I just hope they said if it's within 70 seconds, they said that they have to completely reset terminal, which I don't know if they have time out there. They got 1 hour and 20 minutes, right? Yeah, 1 hour and 20 minutes to reset for an opportunity today. Of course, you guys see that we do have the local time there on our
As a
screen as well.
reminder of what our launch director said earlier, this is the last opportunity that our team can call a hold. So the team chose to take that option at T-minus 70 seconds and ensure everything is nominal before we go into our terminal count sequence.
Oh. So it's
Again, what you're looking at in
Strong
front
back
of you
retracting.
is 85% 3D printed, and it is about to fly. Those white clouds you see
This is
coming
good.
out of the
This is
rocket
good.
are due to the venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds.
So I'm gonna just kind of watch their clock right now. This could be good. Notice that they are retracting the strong back. That's a good sign. But they are still pressing forward, actually. So I'll try to answer these questions about the...
I'm hearing that our T-clock will resume in about 1 minute.
Yes!
Announcement on countdown. This is the LD. The T-clock will resume in approximately 20 seconds, transitioning to terminal count.
Oh, I just got goosebumps. Yes. Yeah, they just paused to make sure everything's normal. Little nominal check. No big deal. Okay, I'm gonna just...
As a reminder, from here on out, when the T-clock resumes, our countdown sequence will be automated and controlled by the internal flight computer.
Remember, in case you happen to be tuning in right now, they are coming out of the hold relatively soon here, so they actually are still going. It's not a full scrub, not a full reset. Venting has stopped. Still in a hold for now. Maybe they just cut the audio for now. But what you're hearing, a lot of that venting is, again, you can see the flare stack.
We are extending the hold just a little bit longer. We're going to stand by for further updates from Mission Control.
Definitely a better safe than sorry moment
Announcement on Countdown Net to the LD. We have had a terminal count aboard, saving the vehicle and assessing recycle options.
here. Sounds like they tried to get into the terminal count the last 70 seconds, and they now have a full abort of them. How I interpreted that. I might be wrong. But that's how I interpreted that, and that might mean that they are looking to see...
You heard that announcement from our launch director. We're going to have an update momentarily as to what happened with our automated abort.
Oh yeah. These are the pains of first rocket launches, my friends. I hope that you guys are, have your patience pants on. It's a first time ever for this rocket to ever try to fly, so this is quite normal to get this close to T0. Already getting down this far into the launch without any serious issues is already a very good sign of things to come, that they're, hopefully not working any major issues. The fact that they got that close to terminal and beginning to get into terminal count the last 70 seconds. I'm guessing we're going to see the strong back, the thing that holds the tower behind the rocket, that holds onto it. I'm guessing we'll see that actually go back to the rocket and hold back onto it. It's a good safety feature to have. In case of sudden gusts of wind, you want to minimize that time where it's not being supported at the top of the rocket. We're seeing a large flare there from the flare stack, so that is meaning they're venting out a decent amount of methane. That could be as they begin to reset and look at what it's going to take if they have enough propellant reserves on hand to be able to recycle and refill the rocket again.
If you're just joining us, we did have an automated abort at T-minus 70 seconds. The team is currently assessing if we're able to recycle, since we are still within our launch window. So we'll provide that update as soon as we have confirmation from Mission Control.
All right, well, yep, we had an abort now, which is a little bit different than a hold. So, like I said, they do have 1 hour and 13 minutes left in their window. So they still have a decent window of time here to get these things figured out, see what triggered the abort. So many times in a situation like this, it can be, especially when you have 9 engines, It could be something similar to like SLS, how SLS had one of the RS-25 engines saying like, I don't like the temperature I'm at, I'm not cooling down properly. Coming to find out it was just a sensor. Now lots of times you can override that. You know, in this case, they had other telemetry. They can see, for instance, you can see whether or not propellant is flowing properly through the vehicle and draining and venting. Then you know for a fact that some of your cryogenic propellant is moving through this point and leaving this point. You can safely assume that it's going to be at proper operating temperature, and you can use other systems to confirm that. But at the time, they were being, you know, out of an abundance of caution, they were not willing to risk the launch of SLS based on what could have been erroneous sensor data. They found out afterwards, after they scrubbed, they looked at the data and they go, oh, yep, all of these other signs did point to this engine was at operating temperature, but our sensor told us it wasn't, so they did abort. Now, I'm not saying, obviously, I have no information on what, what is going on exactly in this case. But, you know, when you have 9 engines and stuff like that and you're getting into that final bit, all it takes is one of those sensors to be like, you know, I'm not at the right pressure. And then they might have to, you know, scrub it. And sometimes that can be just a simple reset. It can be recalibration. It can be all sorts of things. But we'll have to see. We'll have to see, you know. We don't know until we know, so we'll wait to hear more information. And meanwhile, I'll try to answer more of your questions as well. So again, I'd never really finished the questions on why do they use cryogenics. So again, it's just the state that matter is in. So hydrogen is a phenomenal fuel in the sense that it's the lightest molecule, and that means you can actually shoot it out of a nozzle quicker. Say you have the same potential like pressure behind something. You have a cannonball versus a tiny little bullet. Obviously, it's the same total energy, except for that the bullet is able to travel faster. And that's actually more efficient. You actually do get more, your escape gas velocity is directly proportional to how efficient your rocket engine is. So shooting hydrogen out of an engine, which is a very light molecule, versus a heavier, like carbon and things that come with kerosene, that's just a heavier propellant. It doesn't work as well. Its specific impulse is actually worse. So the fuels that we are most appealing on paper, at least, is hydrogen. You're like, oh, hydrogen is amazing. We can get 450 seconds of specific impulse. That's incredible. Versus like 350 if we're lucky, for some of these other propellants. So yeah, almost a 20% increase in efficiency. And you're like, heck yeah. Then you realize, oh, it's like 7 times less dense or something. So now the tanks are going to be substantially larger. So there's all of these trade-offs, but in order to get hydrogen, and if you had hydrogen as a gas, it'd be like 1,000 times bigger or something. So the rocket would be so heavy you'd never be able to leave the pad with hydrogen. So you cool it down to the point where it's a liquid. So that is the cryogenic property that it's cryogenic is so cold that it turns into. You get it all the way down to the point where hydrogen is a liquid. That same thing is true for this rocket with methane. Instead of it being gaseous methane, you cool it down to whatever it is, 160 or whatever degrees Celsius. It turns into a liquid. So it's so cold, that's how cold it has to be in order to turn into a liquid, to densify to be able to fit inside of the tanks, basically. And then, or to make the mass fractions feasible. If you were to try to use gaseous propellants, the mass fraction of the rocket would just be so big you would have no payload left. I'm pretty sure at least from what I know, and at least what's common practice, I don't think it's possible to even make a gas-powered, gaseous propellant-powered rocket that could make it to orbit. So that's why cryogenic. And on that same note, then Crassy asked, well, what does propellant conditioning mean? Cool it off. So in this case, you have to make sure that the propellant inside the tank stays as a liquid. So that means continually topping it off and venting out. And what's crazy, because of the laws of thermodynamics, venting the gas out actually, reduces the pressure inside. So therefore, it actually decreases the temperature. So it's this whole balance of like venting and backfilling and topping off and venting and blah, blah, blah. And you just are maintaining the proper conditions between pressure and temperature and volume and all that fun stuff that I don't know anything about. So that's what they're doing, just continually conditioning, making sure the propellant is at is A-okay. Let's see, Muddy Creek Critters, thanks Tim for all you do and your team. Space Lobsters rock. Are you going to have any more rocket collectibles? I love my Falcon 9 model. Yeah, again, see our poll. It looks like the Space Shuttle and Buran are actually catching up to the Saturn V. I think I would be more tempted, honestly, to do a Space Shuttle versus Buran next. I don't have any good space shuttle models besides the Lego one. So just for my own personal collection's sake, I think I'm pretty inclined to do a space shuttle. I don't have a Baran model at all, and I would love to because it has the RD-170, which I'm a huge fan of that engine on the Energia booster. So personally, I'm leaning more towards space shuttle. But if you haven't voted yet, you have 9,000, almost 10,000 votes. Do me a favor and tell me that you would want the space shuttle and or Baran. They wouldn't necessarily come together. You could buy either or. But I'd actually almost be more excited about owning a Baran because there are space shuttle models out there. Most of them are wood or low fidelity. I would want it to the same fidelity of what we have here. Yeah.
Once again, we had an automated abort at T-minus 70 seconds. Our launch director and our teams in mission control are currently assessing the recycle options that we have for today since we're currently still within our launch window. We're standing by to hear that update from Clay Walker.
All right. Down but not out, my friends. They still have 1 hour and 6 minutes left in their window. We're coming up on, an hour and 6 pretty much. Leg end, do you think we'll ever get to the point where weather conditions will not have an effect on launching besides extreme weather? I mean, it all depends on the provider. I mean, look at Soyuz and Proton. They've launched those things in very not ideal conditions. They just send it, and that's just a risk that they're willing to take. There's a certain, I don't know. I think each provider and I guess U.S. regulations probably also deem certain conditions safe or unsafe. So it's hard to tell exactly what would need to change before we could launch in more extreme environments. But the big thing too, specifically with rockets, is not just that one of the biggest constraints is not just the ground wind, but it's actually when the rocket's ascending into the upper levels of the atmosphere. Because upper level winds change really quickly. You'll have one layer of atmosphere that's moving at, I'm making up numbers, 100 kilometers an hour west. And then immediately after that, the next layer is moving at 100 kilometers an hour east. And so as your rocket's ascending, it can get through those two layers within a brief moment, in a second or two. Again, making up numbers, but you get the idea. And what happens, I love having a model on display. I'm going to keep this kind of loose in here. What happens is as you pass through these I'm actually going to, we'll go full screen on this so you guys can see my demonstration a little bit better. As the rocket ascends through the atmosphere, you can have bending moments where it's actually twisting it like this. And a problem like the Falcon 9, for instance, is one of the finest finest rockets, not model rockets, that's a fine model rocket. But the finest ratio is actually its length to its width. So how wide is it compared to how long or tall is it? And the Falcon 9, to my knowledge, is still the finest rocket. So it does mean that it has some structural limitations when it's ascending through the atmosphere. As it hits those layers of wind, you can have extreme direction changes. And it's not necessarily like the wind itself is going to break it, but it's the bending moment of the engines having to gimbal against the wind on one direction, having to go against the wind on the other. And if it's too strong and too steep, you can just snap your rocket in half. And those of you that have played Kerbal, especially KSP2, are maybe familiar with those bending moments that can be induced by engine gimbals. So that's still that's just a big thing. Unless you overbuild your rocket for those conditions, it's again a trade. Like, how many launches are we scrubbing per 10 years that we, versus our payload mass fractions and our cost of our rocket? Like, were we missing out? And at some point, this is a trade study people are probably doing. Like, what if we made this 7% stronger? Would we have not had to scrub these 4 times? Those 4 scrubs cost us $6.8 million. But it also would decrease our performance by X, Y, and Z. How many customers would we have missed out on because of loss of performance? I mean, these are the trades that people have to do every single day with spaceflight. So, that's a big one. And but a vehicle like Starship potentially is a lot less fine than the Falcon 9. It's a lot, wider compared to its overall height. But the problem with Starship is that it flies with its flaps out. So there's a chance that bending momentum, a sheer force of wind in the right direction could hit those flaps on ascent, and the engines would bend so much. I mean, that's my biggest fear. I can't believe they're not tucking the fins in. Now, they're not going to do a lot when they tuck in because it's still some aero surfaces, but it's a lot better to me than having them all the way out. And I'm just really surprised that those extreme wind shears in different directions, like I don't see any point in them having them out versus having them tucked in. Would slightly reduce that by a little bit. So there we go. I love that I tried stuffing our poll, by the way, and you guys still are at 37%. We're on 39. I guess they're catching up. I'm trying to cheat this so I'm not having to try to produce the Saturn V and N1 rocket. Because like I said, that's going to be big and expensive and scary and everything. The hold time has moved. Hey, that's a good sign. Oh, we're coming out of a hold. I will remove our hold, looks like. Mary Liz, I'll let you do that. That's a good sign. Hold time has moved. We have a new T-minus 46 minutes. Okay, so that's going to be like 35 or so. 3:35 local time-ish. Hold has been removed.
All right, I just received confirmation that we are going to recycle, and we have an updated T0 time of 15:55 Eastern. So again, that's 15:55 Eastern, approximately 45 minutes from now. We're gonna keep going.
I love it. Do it. Do it, I dare you. Double dog dare you. All right. How's our poll? 37, 39. There's 21,000 of you out there. We have 10,000 more votes in our YouTube chat that can skew our vote away from me having to try to build a Saturn V and an N1. Although I'm going to do more extensive market research than this because, yeah, I don't think this is great market research.
To provide an update on the cause of the previous automated abort, the stage 2 oxygen temperatures were out of limits, so that's why we had that abort at T-minus 70 seconds. Now we're going to resolve this issue and continue on with our recycled and new T0 time of 15:55 Eastern.
Sorry, I know our clock's going all sorts of wonk city right now. This is we have a new backend for our overlay, and it's going to be amazing. It already is amazing. But it allows people from, like right now, Mary Liz is in Texas controlling our overlay. I'm here in Iowa doing this stream. We can set up and do things in a way that just wasn't possible before. So we still have some tweaks to do. I think we'll probably be hiding that clock that's bouncing around. Is that because we aren't using a mono-spaced font or what? Why is it bouncing around? Fascinating. Yeah, it's going to be 2:35 our time is the T0. So hopefully she'll get that figured out. Like I said, we still got some teething pains on this, but we'll get it figured out here. All right, so this is from DeCarl. One of the reasons for 3D printing is that you can actually build stuff which would be basically impossible in traditional manufacturing. Yes, that's 100%. Like I said, that's the beauty. You can have intricate cooling channels and things that would be. It's hard to say impossible. I mean, there are things that are impossible, but there's a lot of brilliant ways you can do things in traditional manufacturing. It just can be extremely hard to do, and that's where 3D printing, especially when you make changes to those, that's the thing. It's like, you're not shoehorning yourself into those types of things at all times. All right, Dirk, from Dirk, shoot, what upcoming rocket are you most looking forward to aside from Starship? Aside from Starship. Good call, because that's obviously something I'm quite excited for, hopefully this month. But this is one of those rockets that I've actually been waiting a long time to see. And if I hadn't totally worn myself out hardcore with traveling back and forth for Firefly and Artemis in the van, this would have been one that I probably would have liked to see live. And maybe some upcoming launches I might still pop over to Kennedy Space Center to see live and not stream at all, just enjoy them for myself. Sorry. But other than that, I'm actually really excited to see Vulcan fly. I'm excited to see our first methane-powered rocket make it to orbit. And right now, this is on the pad. This has a decent chance of making it to orbit. I will say though, they're treating this a lot more developmental, a lot more like a proving ground rocket than Vulcan. Vulcan is expected to fly and be successful on its first launch. Like, it would be pretty upsetting and a pretty big boo-boo if it wasn't successful on this first launch of Vulcan. This rocket, on the other hand, if it makes it off the pad and clears the pad and doesn't destroy the ground infrastructure, that's already like, sweet, we did it. You know, that's a positive. So just the benchmarks, you know, the bars here to try and pass are totally on different levels between these two rockets. So I, again, of course, meaning well here with Relativity and Terran 1. I hope they make it to orbit. That'd be incredible. But I don't really quite expect. I mean, there's a lot of things they'll have to try to prove out in their first launch. If they get through all the major milestones, I will be very, very impressed, though. So, yeah, for me, like, what rocket am I excited to see fly? I would love to see just the first methane-powered rocket. I mean, and of course, Starship has the potential to be the first to make it into orbit, too, as a methane-powered rocket. But it's just hard. It's hard telling at this point, really. It's very hard telling what's going to be first. And, yeah, again, Starship's quite developmental, and they're kind of just hoping the same thing, like get off the pad and don't destroy our launch infrastructure. And anything after that is like, sweet, we got data. So I'm not necessarily expecting to see that thing make it fully to orbit all the way either. So I guess time will tell. Other than that, what else am I looking forward to? I mean, New Glenn to me is one that I'm really excited, but that's so far away. I'm excited to see Boeing fly humans on Starliner on top of an Atlas V. Oh, new launch time again, 3:45. So we're going to see this launch clock move again to... Oh, did they already move it? I thought they said 35. Oh, well, yeah. I guess launch clock is still on, so... all right, let's keep going here. What is this? Jim Kerman, is there any word on the Russian PTK or RAL spacecraft entering service yet? Or is it still way behind schedule? Is the PTK, hang on, let me look this up. I'm thinking of, okay, so the oral was,
Launch time that's been confirmed with the range is at 15:45 Eastern. That is 3:45 p.m. Eastern. The T clock at the top of your screen is accurate and will keep you up to date as to when we are going to lift off.
Okay, cool. Yep, we figured that. So they probably set a preliminary time, then it got approved by the range, the people that are clearing and making sure there's no aircraft and personnel, boats, shipping, and things like that in the path of the rocket at all. So I have not heard anything about this for a long time. If I recall, this was wasn't it originally based off of, I thought it was based off of, what was that other vehicle they had? In like the 80s, but maybe it's not. I don't know anything about it, frankly. So I'm sorry, I can't. I'm definitely not your guy for news on that. Thank you so much to EDub. I appreciate the membership and the support. That means a lot. Let's see here, Kevin Miles. Can we make models of rockets and other rockets that are actually launchable? If you want that, SpaceX actually sells a launchable, model rocket, but then you're dealing with a cardboard model rocket. It's not going to be nearly as highly detailed. It's not going to be, have movable features and things like that. I personally wanted to do a rocket that, could have landing legs that extended and all these things. Making one fly just gets into a whole different thing. And then you end up just having to make make pretty big compromises to the detail. And, with us, especially like when you see, on the raceway even, I mean, these are the types of things that they wouldn't have it so the grid fins can deploy and be moved. This would not go on a flying model rocket. Obviously, the first time you fly it, it'd break off right away and it'd be a no-go. So all those little details, the little raceway details, again, having removable landing legs and collapsible landing legs, having 9 engines on the bottom, all of the details that make this a proper scale model, a lot of that detail would go away. So for me, it was more important. I like the fidelity a lot more than the ability to launch it, which I personally would probably just never do. So that's the way I went with it. But yeah, I would look into that if you are interested in that. Jamie, thank you so much for becoming a member. Bernard, we've definitely asked this a handful of times, or this is the question that we get all the time. The big thing is it's a technology demonstrator for them at this point. They're really just trying to prove out at scale how much validity is there in 3D printing a model rocket. And again, they easily could walk back from this point, but by doing this all up test like this, by having 85% of the model or of the rocket 3D printed, they really will validate like everything as much as they possibly can, and then make decisions from there on like what is worth it compared to traditional manufacturing, what is not. But this is, I think, at this point, frankly, just a flex to be like, here's what we can do with our technology. How amazing is it, you know? So, let's see. Which part of this rocket is 3D printed from Snardog in our Discord? Most of it, 85% by mass. So literally the walls, the tanks, most of the inner stage, like you get down to small component level things, you might not have it be 3D printed, but literally where those components might bolt onto might be a 3D printed structure. So literally, like, you know, bulkheads, the raceways, most of the engines are built using 3D printing technology. So it's, if I remember right, they're trying to I think Tim Ellis said that they're trying to get the number of parts that, you know, you have to assemble together. I think it's an order of magnitude less assembly on this rocket compared to a similar rocket. So you just think about the places where there might not, you know, where you don't have human error and just all that labor time and things like that. That's where the real potential for 3D printing comes in. Abraham wants to know, do I think the first person to walk on Mars should be a businessman like Jared or a pro astronaut? I don't have a strong opinion on that. At the end of the day, it's a human being. The motives could be totally different between the two people. So I think this whole thing is getting turned up on its head, where people have a negative connotation with billionaires doing joyrides to space, because if Jared Isaacman is able to service the Hubble Space Telescope for free to the human race out of the goodness of his own heart, that changes everything. That changes everything. I'm sorry, but no longer can people be like, oh, billionaires and their little space joyrides. Sorry, I'm not saying that you're saying that or that everyone out there has that tone, but there's definitely people out there that have that tone. You know, like all over the news and podcasts, I hear that tone all the time of like, oh, just another billionaire doing a space joyride. At this point, Jared is literally investing and pushing humanity forward into, you know, adventuring and exploring and science. And that's what they're looking into right now with NASA is, can they privately fund and service the Hubble Space Telescope? So if they can do that, and if he's going to be the first person to fly on Starship, I don't see any reason why him or someone like that in that position that wouldn't be a traditionally trained astronaut wouldn't have the opportunities and wouldn't be a perfect fit to be able to be the first humans on Mars. You know, if they can do it cheaper through not having to go through all the bureaucracy of a government program to be the first people on Mars, if they can take greater risks, if they can do all of these other things, you know, if it could be a commercial venture in the sense of even like the advertising of the live stream even. I mean, that's not going to pay for an entire Mars mission, obviously, but you know, there's other revenues. I'm all for it. I'm all for whatever gets us deeper into space, pushes our technology further, gets us more frequent launches, gets us on the on the moon properly, where we actually are sustaining, moon and doing like lunar manufacturing, space hotels, all of the things that seem like science fiction. We're actually getting to the point where we're seeing momentum in that direction for the first time. So I don't care who lands on Mars as long as they're a decent person representing humanity. And if that's Jared Isaacman, I can't think of a better person. So I don't know if he's ever talked about whether or not he would even want to go to Mars. But yeah, if he started funding it along with SpaceX or something completely privately, I'm all for it personally. But all right, Spencer, thank you so much for becoming a member. To all you new members, don't forget we will be doing. You can check links right now. I need to update actually because I have uploaded the final. Really hope it's the final version of how to start a rocket engine. If you want to be one of the first people to review it and make sure that we don't have any errors before it hits YouTube, it's going on YouTube tomorrow. So stay tuned. I hope you guys all set your alarms for about 10-ish Central, like I said. So probably about 16 or so UTC, hopefully for sure before 18. If it's not up by 16, look for 18. If it's not up by 18, we have a serious problem in the video, and I'm like re-uploading and scrambling to re-encode and re-upload and blah, 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 blah. So stay tuned for that. If you remember, after the stream ends, I will do the final link for the final watch through. Get some more eyeballs on it. Just make sure we don't have any errors or render issues or especially spelling errors. That's like my number one problem is spelling. Let's see. This is from Boko Moko. Why not have more specialized spacecraft? Why the hell does Orion has to carry its heat shield all the way to the moon and back? Wouldn't it be better to have landers, lifters, orbiters, pushers? It actually makes it more complicated when you end up with having to do another rendezvous back from the moon. So the Earth-Moon system, at the end of the day, it typically makes sense to aero brake back into Earth orbit. So if you don't have a heat shield and you're trying to get back into, say you wanted to rendezvous with a lander vehicle that's in low Earth orbit. Hi there, that's cool. Coast Guard probably checking for the range is clear. So say you want to get back from the moon and you want to get back into low Earth orbit and rendezvous with an entry vehicle that has a heat shield and a parachute. Well, if you're not going to use the Earth's atmosphere to your advantage to slow you back down from lunar orbit, you have to have a stage as big as the stage that kicked you out to the moon to slow you back down at Earth. You know what I mean? So if you're not going to use the atmosphere to slow you down to get into low Earth orbit, you have to have a stage that's capable of, 3 kilometers per second. So a whole like Centaur upper stage or whatever it was has to go around the moon with you to slow you down at Earth. Now, of course, you can do things like, less aggressive passes. But at the end of the day, the safest, most direct, and it's really not that big of a deal. You're not having to break up into a whole other spacecraft and have that up in orbit too. It's just better just to take that heat shield out to the moon with you and return in one foul swoop. Do the whole reentry process and have it all, have the Earth's atmosphere do as much work as it can for your mission. At least that would be my understanding of it. A lot less complicated. Imagine if something where, you go out to the moon, you do your reentry, or you're trying to come back to rendezvous with your Earth landing vehicle. You get all the way back to Earth. You realize, oh God, we came in a little bit too shallow. Now we're reentering and we don't have parachutes or a heat shield. Or, oh God, now we're totally on a different orbit and we don't have enough propellant to match back up to that lander, or blah, 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 blah. It's just a lot riskier, and it's actually just more sets of hardware to do the same thing, Hopefully that answers that question. Let's see. This is from Enrico. Would love to order some of your merch, but shipping customs to Europe are crazy expensive. Any plans to have some European distribution? We've talked about this every time. Right now, shipping costs to Europe are insane. We didn't do any favors with this thing because it is, like I said, it's like 2 kilograms. I think the shipping weight is over 2 kilograms. So now that's just insanely expensive. We should probably send a couple pallets over to Europe and figure out the logistics for that. Unfortunately, just at our scale, the scale that our shop is, having a European distribution is just it's just kind of out of the question for us. We're too small of a shop to do that. If we did like 2 or 3 or 4 times the sales annually, sure, we could do that. One of the things that we try to do to make it a better shopping experience internationally is we include, when you are checking out when you're shopping, you are seeing the price of what it will take to get to your doorstep. It'll prepay customs, it'll prepay VATs and taxes, it pays all the fees so that it gets through customs and gets to your doorstep properly. Our old way of doing it was like, we'd send it to you and then it would get stuck in customs. People wouldn't see the letter in the mail from the customs office being like, we have a package for you. And it would get stuck somewhere for like 2 months, and then people would get stuck with like a 40 euro fee or something to get it out of customs. And we can't control customs really, but what we can do is be proactive about it and prepay those for you so that you have that all baked into your price, so that you're seeing the actual price of what it's going to get to your doorstep with all with proper tracking as best as we can, as opposed to USPS being like, we sent it, done, and people think it's just stuck in LA for 2 months. That's the best we can do right now. At least there's no surprises on your end, and if your taxes are too high, talk to your government about that. I don't know. We're just paying the customs, and that's just what the customs cost. And unfortunately, it's what the shipping costs. And even the shipping, we actually discount. Like literally, we get a quote. We measure, and the shop has a price for how much it costs to actually ship these things. And we actually discount it beyond that. So what you're seeing for shipping prices are actually cheaper than what we're getting charged to ship. And some things to certain destinations are still like, almost makes it like, back in the day we had 2 things in the shop at one point that if you had the right location and the right packages, we'd actually lose money shipping them to you. We'd lose money like in the whole sale altogether. So we're trying to not do that. So yeah, we're still trying to make it as reasonable as we can. We know that European distribution would help a lot. Right now, shipping is just insane. Customs are insane. There's not a ton we can do, but like I said, someday we would like. The solution would be if we get enough demand for this, and if we could offer, a 50 euro discount or 100 euro discount or something. Obviously, that would be pretty advantageous and would open up a lot more doors for people. So we would try to figure out if we could send some pallets, but that just, that distribution becomes a nightmare. But wait, when did I say Matt's name? When did I say? I didn't say Matt's name, Andy. Why am I getting the pronunciation of Matt Lown? I don't think I said Matt Lown yet today. That's funny. Okay, Patrick Walzer celebrating 42 months of membership. Thank you, 42. Great number. 42 months, that's a lot. Thank you for your wonderful content. I'm hoping for a lot more in the years to come. Greetings from Germany. Thank you so much. Obviously, that much support just really means a lot. Mary Liz is excited about 42. Of course she is. Chris Fields. I just want a 1/144th scale of each rocket I personally worked on. Shuttle, Atlas, Delta, Vulcan, Falcon, SLS. I have an SLS already, an older version. Holy crap, Chris. Shuttle, Atlas, Delta, Vulcan, Falcon, and SLS. That is quite the heritage there. Yeah, I want all those rockets too. First, I don't love 1/144th scale though. It's just like, it's a dumb, anything other than 1/100th doesn't make any sense. Like what? 1/144th. Like if you look at it and you go, yeah, now you just divide it, times it by 144, and you like, it's just hard. For this, I can pick it up and go, oh, I know this is the real booster's 45 meters tall. This is now 45 centimeters. It's a lot easier. I want everything to be at the same scale though. That's like the whole point of our model rockets, is to have everything at the same scale, 1/100. We're just gonna keep it that way. Unfortunately, your SLS. Your 144 scale SLS, that's another one I would love. SLS is a rocket I would love to have to scale. I just think that's like so iconic already. And it'd be really fun to see SLS, Saturn V, and N1, and Starship all next to each other. Like that would be the coolest thing. Let's see here. Lawn Dart. 76 miles north and clouds are clear. I hope to get a good view outside now when I go outside. Londar, I hope you and all of us here get to see a beautiful launch today. It does look at that sky. It looks blue. It looks like it's clearing up compared to the beginning of the launch window. I really hope that we are able to see a launch today. The Space Taoist. Hey, Tim, any quick, and thank you, by the way, Londart, for your tip.
Minus 23 minutes and 56 seconds. We're currently waiting for an update from Mission Control. Let's continue listening in and stand by.
All right. Let's see. I'm going to go back to this. But again, thank you, Londart, for the tip and for this generous tip too from the Space Taoist. Any quick thoughts on the viability of using launch vehicles for intercontinental surface-to-surface transport? I mean, I think it's within the realm of physics. Yes, I don't want to say no, because I think in the grand scheme of things, why not? Once you work with a system enough, originally working on, airplanes would fall out of the sky originally because their fabric wings would get a hole in them. People just thought this is never going to be reliable. We obviously made some major upgrades to the reliability of airplanes. Now they're so reliable, it's just unheard of. Rockets are still in that territory where, we can't really imagine, oh man, all it takes is one, leak or a...
Announcement on countdown net, this is the LD.
Oh, sorry,
We're scrubbing operations for the day. Thanks for playing.
Crap. Scrub. Full abort.
All right, you just heard update from Mission Control. We are unfortunately scrubbing today's operations. We're going to stand by for additional details from Clay Walker.
All right. You heard it. I'm going to reset the title and do a quick tweet. I'll be right back with you. So if you see me doing nothing, that's why. 1 second. Okay, crap. Well, people are asking now what? Now we look into trying to answer more of your questions. Discord. We don't know. I don't even think we have a new launch date on the table yet. But let me get through some of your guys' questions here while we wait, and then I'll stick around and try to get through the rest of our queue here, since we're all set up and going anyway. But yeah, the surface to surface, point to point transportation using rockets. Sure, someday we'll have enough data, enough backups, enough understanding on how to make a vehicle safe. But it is just a different beast compared to an airplane or any regular vehicle. The big thing too with airplanes is obviously most of the stuff can fail and it still will at least glide. It won't, assuming the structure of the vehicle doesn't fail, it'll still glide and still be a vehicle. A rocket, on the other hand, all it takes is like a little crack in the tank and the whole thing's done for. It's fighting gravity. It has to work against gravity, at least on ascent and on landing. Like it doesn't have any like passive way of doing any of this stuff. It all has to be, you know what I mean? As opposed to an airplane has like the air to work with and it's just passively already a flying object. A rocket has to be doing everything working right in order to function. That's just the way it is. So it's going to be a little while before we get that kind of redundancy and backup and everything before that's really a valid option. But SpaceX thinks it's possible. The Air Force and Space Force and Department of Defense thinks it's possible. They're doing some funding on the viability of transport, like instant transport across anywhere. So that we'll see. Michael, thank you so much. Very generous tip. Thank you so much, Michael. Congrats on Dear Moon assignment. You are representing all of us armchair astronauts. Very happy for you. Keep up the great reporting work at Astra. Thank you so much, Michael. That really means a lot. I obviously can't wait to be able to provide coverage and document and share my experience of what it's like to go around the moon with all of you. That's going to be amazing. Let's see here. Won't a 3D from Al Horan, won't a 3D printed rocket structure be inherently brittle? How would the weak points between print lines work? Porosity of the metal, not a factor. This is all stuff that they had to solve. I mean, that's to get here even. They've obviously done structural testing. They've obviously loaded it with propellant. They've obviously done answered all of the questions that you have, and they had to develop technologies that would solve that. So obviously their 3D printer is not just an off-the-shelf 3D printer. 3D printing, especially, what's that called when you do the layer by layer 3D printing? Not additive. What is that? What is that 3D powder printing? There we go. Yeah, powder printing, exactly. Where you're just basically going, around with a laser and you're merging all the metal in like a bath of powder, basically. Has the ability to be extremely fine without those issues. Now, so they had to develop a lot of technology to be able to make it so this is even possible. But and PLA, yep. PLA is another one. Yeah, it is pretty impressive. Sebastian, why can't SpaceX with Starship covered its launch pad with a rocket engine cooling system to save it from being destroyed by the exhaust? So why can't they put the launch pad to use like regenerative cooling all around the launch pad? You probably could, but you need just an insane amount. You really, really, really need an insane amount of energy to even run that system and to have the heat exchangers and things like that capable of removing the heat from the system. I don't know. I mean, I wouldn't be surprised if they end up with some kind of like actively cooled launch pad at some point. You know, if they're looking at rapid reuse, rapid iteration of even the launch pad, sure, why not? Kind of a classic, why don't they just?
Word from the launch teams, we're scrubbing for today's launch temp due to A, remove that and put in her first.
Whoops. They're working on their their script here. Hey, I've made some mistakes in live streams, so they're doing a phenomenal job. I gotta say, actually, props to the production team here at Relativity and the hosts for doing such an outstanding job. For their first attempt ever at this, they're doing phenomenally. I know what it's like to be doing all these things and having to talk to people in one ear and someone else next to you in the other ear and all the things and all the stuff and all the data. It's very hard. It is very, very hard. I don't actually love it. It's a lot of stress. And then also to be the ones in charge of the actual physical production was also just a lot of stress on top of stress. And then on top of that, like trying to worry about scheduling with SLS and Artemis and stuff was a lot. So, but they're doing such a great job. For a first live stream, outstanding work. I mean, not even for a first, just for a live stream. I don't need to, for our first one, like just a generally great job. All right. Did I answer that question? Yeah, maybe they will do an active one someday. Edit K, what do you think about India's ISRO and its future, and how can it compete with companies like SpaceX and NASA? Well, I think that ISRO and JAXA and Roscosmos and CSNA, I think really all of these organizations shouldn't be competing with SpaceX. I don't think that should be a thing. I think an Indian-based company should rise up and with the knowledge at ISRO and with national resources and talent, start building rockets that compete with SpaceX. I don't see any reason why organizations, a government organization, needs to be competing with a company like SpaceX. That isn't done anywhere else in the world. Again, like no one in Indy right now is like, I really hope.
We unfortunately scrubbed for today. While we obviously had high hopes for sending our Terran 1 off today, we're going to continue to take a measured approach so we can ultimately see this rocket off to max Q and beyond.
Once we have an update on the timing for our next launch attempt, we will share that via Twitter at Relativity Space. We hope you will join us again soon to see the world's first 3D printed rocket fly. I am Rachel Aniceto.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.
Again, everyone, round of applause for the production. Fantastic work, really. The hosts did really, really great job, great communication. I love the company's openness and willing to share all this stuff with us. So round of applause, everybody. I know that it's a shame we didn't see a launch today, but hey, better safe than sorry. Scrubs are cheaper than booms. Their first attempt ever. No surprise here that they're scrubbing. Even the most prolific launch providers are having to have scrubs. So no big deal. Stick around though for a little bit. I've got a few more things that we can talk about here on our end. But yeah, and don't forget though, too, I've mentioned it a million times on screen now, that we do have our Falcon 9 model rockets back in stock, finally. I know you guys have asked for this. We also have our new full flow stage combustion cycle shirt, everydayastronaut.com/shop. And you can see our wonderful new shirts, poster version of the full flow stage combustion cycle. We have our limited edition gold Aerospike engine, and lots of other fun stuff. So if you want to support me, especially as hopefully tomorrow when you guys see this new video that we've been working for 4 months on, I hope that you guys just get excited and hyped about spaceflight and about rockets and engineering and go, this stuff is really cool, and help. If you want to help me support the work of other people, and helping to explain what they're doing, why this stuff matters, and how come it's so cool, getting some fun merch always helps. So I really, really appreciate that. Thank you guys so much for all of the support and the love. We do have more questions to answer though, so I'm going to get through them. I'm going to get through the queue. Screw it. I mean, people are probably hopefully watching and commenting on our video so far, and I will have some more edits to do, I'm sure, but that video is coming out tomorrow. I can't wait. All right. So back to Israel. Yeah. So again, I don't think you have anyone in the Indian transportation industry today that is working for the government in India going, we need to make sure we have a bus that can compete with, or let's make sure we produce a vehicle that can compete with Cybertruck. You know, like that's not the government's job. So we're still in this weird mindset that back in the day, it took government funding to do spaceflight. These days, with, you know, computers and the knowledge base and cheaper printing method, you know, manufacturing methods like 3D printing, smaller startup companies can do the work that used to only be possible by government. So that's my opinion. Alex Snarsky, what does this rocket cost to print outside of the R&D? How much would it cost to make a similar rocket with conventional methods comparatively? I have no idea. I have no idea. I think there's a lot of R&D and a lot of tech developed in just the 3D printer. But again, we're going to see in the long run what this company chooses to do with 3D printing. They have the capabilities. So they are proving out how valid is the entire everything. And from there, they can make decisions going forward. Again, they're not thinking purely right now about, is this the best way to make a rocket? It's really, let's prove out 3D printing, see what we can do with it, and then think about how that can best shape the future of rockets and structures on Mars, structures on the moon, space structures and space things. They're not just like, if they can build a rocket almost entirely from 3D printing on Earth, then you could, in theory, build incredible things on Mars as well. So that's their goal, is like prove this technology out, go from there. Let's see. For those of you that are commenting, when's it going to launch? And then all that stuff. Notice it says scrubbed right here. The title says scrubbed. This launch has been scrubbed for the day. We are just into the aftermath of that and answering questions. Thank you so much to Senti. Appreciate. Let's see. Matt. Hey, Tim, what is your favorite sandwich and why? Oh, man, Matt. It's an SSTO sandwich capable of single-stage orbit with a little bit of smoked turkey. I don't know, my favorite sandwich. I like turkey. Okay. I'm a bread guy. Give me that bread. I really like a good ciabatta, like when it's almost more air than it is bread, and it's like just fluffy and crunchy, and you bite into it, and then it's really soft in the middle. And then there's this place in Austin that makes just the best like ciabatta. It's like, oh, it's so good. And then there's slices of smoked turkey. I'd say that's my favorite sandwich. Let's see here. Beamer Geezer, please send a shout out to Ellie in space. Yes, I can't believe that. Our friend Ellie, who she did it, I did an interview with her right around the Artemis stuff. I don't remember when it was, August or September. Such a nice gal. Just broke her femur. It sounds like, I think she was bouldering or something. Broke her femur. That is crazy. That just sounds absolutely horrendous. I've broken 5 bones in my life, tibia and fibula, radius and ulna, different injuries when I was a child. And that was excruciating. I cannot imagine a femur. I already wish her a quick recovery on Twitter as well, because, I mean, God, that's not fun. That would not be fun. And right before Orbital, I know she was excited about making it down for Orbital. Hopefully she's able to be somewhat mobile for that and not miss out, because that would be... that would not be fun. So, cheers, Ellie. Best of luck. Go Relativity, go Terran R. Donald will have to save that for the next attempt, but I appreciate it anyway. Give you a shout out, says Avnish. There you go. There's your shout out. It's 1:15 in India. Godspeed, Terran 1. When do Terran R will go online? What do you think of the future of 3D rockets? I think they lack reliability. I don't think we know anything about their reliability yet. We've never seen one fly. So obviously, again, you can't look into today's scrub as anything to do with 3D printing. We have no idea the reason for the scrub. There's so many other parts that are traditionally manufactured and have nothing to do with 3D printing. I'm quite confident, as they are as well, that the 3D printing of the actual main structure of the rocket is no problem. But I think, like I said, I've said this a handful of times. Sorry, I know 3D printing is like the number one topic here. But in my opinion, I think they're going to just prove out the technology by flying it, see what works, see what doesn't, and then make decisions from that point on. That's in my opinion, the way that good engineering is done, is based on the data that you have, make decisions based on that. How can an engine have ISP? Does the tank size affect that? Nope. So the engine is considered specific impulse. And literally it's really dumb actually, but all it is, it's directly proportional. It's the speed of how fast are the molecules shooting out, how fast is the gas shooting out of the nozzle of the engine, period. That's how efficient the engine is. So if an engine is barely shooting molecules out at 1,000 meters per second, it's not going to be a very efficient engine. Shooting out at 4,000 meters per second, then you take it divided by 9.8, that would be a phenomenal engine. So that's all it is. Specific impulse is dividing it by Earth's gravity, and I don't really know why. Yeah. Anyway, specific impulse is a factor of the engine. The tank size would affect the delta V, which would affect the total range. So you can think of specific impulse as the fuel economy of the, sorry, I'm going to have to use American units here, imperial units. Say your car has a 40 mile per gallon. That's your fuel efficiency. And then your range is a combination of your fuel efficiency and the capacity, the tank size of the car, equals your total range. In rockets, the fuel efficiency is how this is the specific impulse or the exhaust gas velocity of the engine, and the range is basically the range is delta V. Delta V is like the combination of how much mass is it pushing, how much fuel is there propellant is there to do work, and and those. But of course that there's so many other factors too, because then just delta V doesn't always matter, because who cares if this, let's say this has a million meters per second of delta V. Obviously, if it had that much potential, it wouldn't be able to lift itself. Like, let's say this tank was 200 times bigger and it had the same number of engines, it would probably have a lot of delta V, but it would sit there on the launch pad until it's pretty much empty, and then at the last little bit, it would scurry off the launch pad very slowly. So I would say delta V is your total potential for changing velocity. That's literally what delta V means, change in velocity. So that's where tanks and the overall mass fraction of the rocket comes into play, is that along with the efficiency of the engine. All right, let's keep going here. Let's see. I am a complete newbie. Any recommendations on good books that introduce rocket propulsion? So there's, I would say, well, first off, even if not books, I'm really trying to develop a series of videos that help walk you through a lot of these early questions. So I would definitely recommend watching Why Don't Rocket Engines Melt and How Do You Power Rocket Engines. Those two videos really will set you up for a ton of other things and give you a really good sense of how engines work in general. This next video, How to Start a Rocket Engine, will give you even more of a sense. And then the next video I'm working on top of that will give you an even better sense. If you can't see where I'm going here, I'm really trying to get back into those, exactly what you're talking about, kind of these overall introductions to spaceflight and propulsion. And that being said, good books though. I'm trying to think of which ones I've actually listened to and or read. John D. Clark's Propulsion, or Ignition, is good, but it's really dense. It's not so much, it's really almost more about chemistry and the actual physical ignition of rocket propellants than it is so much about the actual propulsion. So I don't always love that, but it's still a good book. But I've got someday I'm going to put all my thoughts together and make a book exactly with what you're asking. Don't worry. James Bramlett, hi term nerd, miss ya. Any new tech in the van for 2023? I can hear you say you'll see it when it's done. Now the van's almost done. We changed out the encoder. It was the big thing. The encoder's the biggest one. Let's see. Other than that, we changed UPSs, the battery system in the van, just to be able to handle, be more reliable potentially. Other than that, no. The technology and the things, the vans, I'm trying to get it into a freeze, a design freeze, because we've spent so much time and money on that stupid van, and we're barely using it. And I don't want to use it. That's the problem too. It'd be one thing if we're using it all the time, but I don't want to be using it all the time. It was just like a necessary means to be able to do Artemis and be able to do Firefly and be able to do Starship. It was like the only solution I could think of to be able to do those well, and at the level of what we wanted. So hopefully no more things on the van. I'm trying to be as hands off with it as I can and get back into finishing videos, which would be great. Let's see here. Pedro, approximately what percentage of fuel put into the rocket is fully lost to venting? I don't know for sure, but I'm pretty sure something like if you fully fuel a fully liquid or a cryogenic rocket, let's say methane or hydrogen, I think you can expect anywhere from like 25 to 50% of the fuel that was at one point used to fill and keep the rocket topped off. So if you, let's just say, forget all that. If you, on a launch day, you go out to the launch pad, you have your tanks full, your ground system tanks completely full of propellant, you take your rocket out, you go and fill it up, and you end up scrubbing for the day, you can lose, I think, anywhere from like 20 to 50% of your fuel to boil off. Which is crazy. Now, that obviously varies rocket to rocket, ground system to ground system, all of that stuff. But I've heard a few numbers from a few different companies and their solutions and their ground infrastructure. It can be substantial. Like, I know SLS, I think SLS, if it is fully tanked and sits on there for the whole time, I think it loses like 25% or something like that. Or maybe 40%. I don't remember. What does a recycle option mean? So recycle would be like, after they've scrubbed, they basically are like, okay, well, we have some propellant in the tanks. It's now kind of getting warm. They have to recondition the rocket and get it recycled so that all of the propellant is back up to the proper operating conditions, which might mean venting some and backfilling and doing all these other conditioning and topping off helium, topping off all of the systems to make sure everything's good to go. That is typically what recycle means. And then just getting all of the software even back up to a new point where they can say, hey, here's a new T0 time. Recycling means like basically just resetting it all to be ready for a new T0 time. Let's see. This is from Nelson Clark. Can't wait for the Vulcan launch because I live near Astrobotic in Pennsylvania and got to see the clean room. Oh, that's really cool. So you're going to see, you saw the place where they are building the first lander that's going to be flown by Vulcan. That's really, really cool. Where do you buy all those model rockets? Well, of course, sorry for the millionth time, these ones are available in our shop, everydayastronaut.com/shop, everydayastronaut.com/shop. The rest of them, I'm trying to make scale ones that are all to scale because all these are a hodgepodge of other rockets from other companies, and I don't love that. I want them to all be the same scale. I want them all to be the same quality. I want them all to be the same look and feel. Yeah. Let's see. Isn't durability much more important than flimsy but cheap frequent construction? Seems like capability with reusability should be the priority. Who said that 3D printing was cheap and frequent construction? I don't think it's about that. I think they consider it to be a fantastic choice for construction. Otherwise, they wouldn't be doing it. I think that in the long run, I don't know. I think I think the biggest thing with 3D printing and the thing that people are missing out on, it's not so much right now, it's not so much like, hey, this is the best option to build a rocket. It's really like, what can we do with this 3D printer? How valid is it? What can we make changes on? How quickly can we iterate on this design and make design changes literally with software instead of even touching tooling and hardware? It's the long game. It's like, we're seeing that the launch industry is only going to get more. It's like the difference between a Formula One car that gets to change and tweak things constantly, and these big designs every year versus a Toyota Corolla where they're like, okay, we did that. Now we get to sit on that design for 7 years. We might do a mild refresh year, halfway, mid-model year or whatever. But it's a different thing. It's the competitiveness of like, we're going to be changing this often. We know that. What's the cheapest way to do that? And that's, I think, the real value in 3D printing. I don't think it has anything to do with cheap and frequent construction. See Master Flex time. I got one of the original Founders models, and one of my landing feet is missing the little tab on the outside of the magnet slot, so the leg slips out. Is it possible to replace those feet? That's a good question. Reach out to the shop. Unfortunately, that was actually, these tabs are new. That is a new thing. That was one of the things that we realized, a little tabby thing. I don't think that it was missing them. I just think we didn't have it. I know that some people just ended up gluing it because of that concern. That is why we made the change. That is also why we tried to make the Founder Edition like a warning of, this is a first try. We don't know how good things are going to be. But I don't know exactly if that's exchangeable. I mean, obviously we could send you that part. I just don't know if it's compatible with the old one. I'm trying to think about how that would be, because we had to add a little slot. We changed, speaking of manufacturing and tooling, we changed tooling and had to make new parts based on that new design. Yeah, the little toe thing is new, and the little slot there is new. Yeah, reach out to the shop. Let me know what they say, and I'll be sure and make a note of it too. You're one of the last ones in the queue here, so I'll send that off right after the stream ends. But thank you for your support of buying it. Sorry to have given you a I don't know answer, but that does mean a lot that you were in the original supporter group. That's hopefully the start of something fun. All right. Awesome. Well, thank you. You're welcome for the Falcon 9 model. I'm so glad that people are happy with it, because, you know, you guys know, and of course, let's see, let's let that go away. Matt Lone, thank you also for purchasing a model. Like I said, I've said this 1,000 times, just so thankful that to be able to make products that I want, things that I want in my house and on my body, and that's what it's all about. So I just appreciate that other people appreciate the effort and the support. So thank you. Eric, thank you so much for becoming a member. I really appreciate that. So yeah, Miss Lisa, those palm trees were really swaying. Will wind speed cause, believe it or not, wind I don't think had anything to do with today's scrub. There was already a scrub. It is scrubbed for the day, no attempt for the rest of the day. So the wind I don't think was any issue. I think it was hardware issues. H. Petty, what advice, if any, would you have for someone pursuing a career in aerospace with a degree in computer animation, but a self-taught full-time programmer, Python for 8 years? Start applying. I mean, honestly, like, yeah, I would just get your foot in the door somewhere. There's so many companies who just absolutely need talent right now. And the biggest thing holding you back right now is just to apply for them. Like, I would literally just start applying with whatever your resume looks like. If you have the desire, the will, and, you know, if you're willing to be self-taught on programming, it already right there shows a lot of intuition and a lot of, you know, people being excited that you would go out of your way to learn that on your own, can be a very big attribute. So at this point, my advice would be just to start applying for some jobs. I mean, there's literally dozens of aerospace careers right now, and I just got to get your foot in the door and get some experience under your belt. And then you can, if you need to move around, if you're not happy with your situation, you want to work at your dream company or in your dream position, then work your way up. That'd be my advice. I have to say I don't have great advice, so I have never really worked in the corporate structure. So I'm. Oh, did I say Lown wrong again? After you told me, I told you can't tell me. Matt Lown. I'll never get it, Matt. I'll never get it. Because whenever someone says that it is a way, then my brain goes, is it or is it not that way? So Andy even prefaced me with it. See, I am Everyday Astronaut, the pronunciator. I can't pronunciate things, period. Matt goes and buys like a multi-$100 rocket for me, and I can't even pronounce his name right. That's the kind of love that I show to my friends. It's so bad. And I hear him say it all the time. That's the worst part. Lown. I need to say it 1,000 times a day. I'm going to wake up. I'm going to put it on my mirror. Matt Lown. Are you guys familiar with Spain's PLD space? The first rocket, Mira 1, is being prepared for its first suborbital launch. I have heard of it. I don't know much about it. But yeah, I'll be paying attention. Suborbital launches are cool. But I'm not familiar too much beyond that, honestly. Thank you very much. Mary Liz, why are you a member? You don't need to be doing that. You have all of the love in your heart already. I appreciate that. Thank you, Mary Liz. Racing R, thank you for your tip very much. Holy cow. Very generous. Which watch will you wear around the moon? Apollo 8 crew were on Speedmaster 321. Dang, a lunar watch question. My first lunar watch question. I mean, I just always wear an Apple Watch, so I don't know. I don't really like collect watches. I just like the convenience of having a watch. So I'd probably wear an Apple Watch. Not very exciting, I know. I don't know. Maybe if like there is a really, really cool one. Maybe if I could, how cool would it be to fly like a flown Apollo one? If I could rent one or something from a collector and wear it like an Apollo watch on an art. Yeah, that'd be really cool on a new lunar mission. I would love that. But I don't know. A lot of that stuff I'll have to figure out. NP, maybe this isn't the best stream for this question. But anyway, here it goes. What is my vision for the future? Hopes, etc. By the way, everyone, real quick, say thank you to Racing R. I really appreciate that insanely generous tip. But what am I hope? What's here it goes. What's your vision for the future? That's a very broad question. I think I was actually just talking about this with my friends the other day. Spent some time in like a historic town last weekend, and you know, it was like a big lead town in Illinois, and just looking at history, we went to like the museums and we were just seeing all of the, you know, lead refining and coal and all these things. And I'm sitting here looking at how like dated and historic and, you know, old things look, and just it's crazy to me that they just had cocaine in their, you know, in their Coca-Cola and blah 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 blah. You know, just looking at all the crazy things, and I'm thinking to myself, what are the things now that our generation is doing that 2 generations from now that like our, you know, grandkids will just be looking like, you did what? I think those things are. I think driving a car will be like, you just manually with your hands. Like, what if you had to answer your telemetry device, you know, or like whatever they have? They won't have phones anymore. It'll be some brain thing or whatever. What if you had to answer that? Like you were driving? You know, I think that's one of those things that'll take over very quickly. That'll be like a 10-year span between it being totally unheard of to drive to being the vast majority of vehicles on the road are not driven by humans. And I think that will increase exponentially because there'll be a little bit of a curve, I think, where people are trying to hold off. But I think the benefits and the safety eventually of full self-driving will be so obvious that it becomes regulated at some point. Eventually. Yeah. The other one, to that same note, is also carbon emissions. I think, like, in the future, they'll be like, you've put a flammable liquid at a pump and you pumped it into your car. How are you not, like, blowing up all the time? You know, like, kids won't understand the concept of you filled your vehicle with a flammable explosive material. Like, how? What? You know, because I just don't think that'll exist in 50 years. You know, outside of collectors and things like that. But I don't think in 50 years you're going to be filling up at a gas pump regularly. The average person won't. I think raising cattle and like massive slaughterhouses and all this stuff. I'm not vegan or vegetarian or anything. Full disclosure, I still consume meat regularly. But I think the way we do it is absurd. Like the amount of energy it takes to raise a calorie. Like if you look at it purely based on like the energy input versus the energy consumed by a human, if that's our goal is to like sustain ourselves and eat tastefully. I don't think that the way we're doing it right now, mass producing corn just to feed it to an animal to fart it out and then kill it after some amount of time and then transport it across the country to kill it, to transport it across the country again in little bags and then sit it on a fridge. The whole thing is like hilarious. It's like, this makes no sense. And it's obviously, forget even like the humanitarian aspects of it. Like, you know, I feel bad about that. Like I generally really like animals. I'm just not disciplined enough to not eat them. But to me, like lab grown meat is an obvious one. I mean, by all accounts, like growing it locally, and having just literally like a restaurant could have like a lab in the back that's just growing fresh meat, and it's literally just being raised by electrolysis basically and growing in a petri dish. And you're like, oh, here you go, fresh, literally fresh. Like there's no chance of it having disease because it's fresh. It didn't come in contact with the GI tract or anything. Oh, and you can eat it raw. It doesn't matter because it's not gross. You know, like to me, that's another like very obvious that will in 50 years be a no-brainer. I think there'll be a little bit of a cultural thing there where it'll take people a little bit of time to get used to the idea of eating lab-grown meat. And then I think lastly, in the future, I really do think we're finally heading in the direction of humans living and working in space like we saw in sci-fi. I think in 50 years from now, there's a really decent chance that that there are massively like commercial operations that get humans to space, and still maybe luxury, very high luxury, like we're talking millions of dollars in today's money. But like I imagine a world where equivalent to today's money for $1 million, you could go and hang out in a space hotel for a week. I know that's still absurd by the average person, but there's a lot of millionaires. And, you know, if that becomes a commercially, you know, I think there's a commercial viability in that. And I think we're heading in the direction where launch prices, launch infrastructure, en masse orbit, all of these things will become cheap enough that that could definitely become an option. Yeah. Let's see here. Started raining over here. That's why they scrubbed. Interesting. The life. I need to see that. Have they given us an update on Twitter? I haven't seen anything, and I don't know a new launch date. So if you're still watching this, I don't know. Sorry if I'm just boring you like crazy. I'll have to check, and hopefully we get an update. Tandra Madison, best new word pronunciation today was succumb as the past tense of succumb. Wait, succumb? Did I say that? Did I say like it succumbed to that? Probably. Propellant thermal conditions on stage 2. The team is working towards the next launch opportunity. In the coming days, check back for... Okay. So that was as of 13 minutes ago. It actually didn't have to do with the rain. They may have been able to fly even with a little bit of rain. But that's it. I made it through the queue. I've been streaming for 3 hours now. It's time I get done with this and finish up and get ready to post that video tomorrow. I can't freaking wait. I really, really, really appreciate you guys hanging out with me and for showing up and all the generous support and all of the new people that got their hands on a Falcon 9 model rocket. It means the world. So that's going to be it for me. I hope that you guys have a... Oh, I got to do the scrub song. I haven't done the scrub song in a long time. I actually have different outros based on whether or not it was a successful launch, or a scrub or like a boom. This is the one that's, it's called Translunar Coast. I kind of made it, I want you to listen to it on the way out and watch the video accompanying it. It's like all gritty and like VHS-y. Actually, it's not VHS-y because it's Apollo footage. But it's that like, that gritty, weird tone. And believe it or not, all the tones in the song is all guitar, just really heavily processed with different, it's all guitar tones that really, really, really gritty. And to me, like I tried to write a song based. I saw this footage one time, and it's the footage in the video of the Apollo 11 crew on the way to the moon. It's like very old school, excuse me, like family video style. You know, it's like over the shoulder, just looking around, looking out the window, and you see these bright glaring lights, and they leave these stains in like the tube, in like the CRT or the tube or something or whatever sensor, whatever it had. I don't know how those cameras actually worked. But it like dragged the like burning light around it. I don't know. Something about it just gave me this feeling of like, this weird tension almost, but still like bright and gleaming. Analog bright gleaming. That's the feeling I want you to get when you listen to this outro. And if you like that song, you can find it on Spotify and iTunes and wherever else you listen to music under Everyday Astronaut. All right. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut. Bringing Spurs down to Earth for let's try that again. Bringing space down to Earth for everyday people. Goodbye, everybody. See you tomorrow morning for that video. You better watch it right when it comes out. Bye, everybody.